wanted to use this spare capacity to bring the bran and germ to our silo, taking advantage of the spare capacity and not increasing the total usage of fuel. We also wanted to answer a question about the supply chain. During the supply chain, every time the cereals are moved, there are some losses that, in our case, we call silo powder. These shortages during the different stages of the chain increase overall logistic costs. Facing these challenges, we set a consortium of 4 entities to study how to sustainably valorize these byproducts from storage and cereal processing. First, our company, Silos de Leixões, as the project leader, a specialist in agri-bulk logistics. Second, German, a miller, specialized in grinding cereals such as wheat, rye, and rice. And 2 non-business entities to support the R&D activities. Catholic University to focus on the product, and INEGI to focus on the technology and the industrial symbiosis. For co-cereal value, we set 4 sustainability goals. In food, develop new granular materials suitable for human consumption using bran, germ that are rich in proteins, for polyunsaturated fatty acids, fibers, minerals, and antioxidants. In feed, because bran and silo powder have short stability, study new pellets for animal consumption using these materials and other natural resources of low value, rich in antioxidants. To guarantee food safety, in connection with the Industry 4.0, the aim was to create a new wireless smart sensor to monitor temperature within the cereal mass. It's a problem we sometimes have to find this equipment, and with the help of INEGI, we try to develop that sensor. And finally, build business models in the circular economy field, able to promote resource efficiency, reduce waste, byproduct valuation, and industrial symbiosis with sustainability, both economical and environmental. Industrial symbiosis means, in practical terms, the recovery or use of secondary outputs from production processes as alternative inputs to other production processes. In order to do this, we employed a tool developed by Cambridge University to identify, analyze the potential of symbiotic solutions, the toolkit for industrial symbiosis, called T4IS, in 4 stages. The first, how to see waste, consists on identifying waste resources using yield analysis and material flow cost analysis. How to characterize waste using life cycle assessment and chemical analysis. We performed a full characterization of all resources. How to value waste, to identify value opportunities, identifying hot and cold spots and the potential market value of the resource. And finally, how to exploit the waste. This involves identifying and understanding the exchange partner, as well as configuring and developing the market creation and the delivery system to make the best use of our waste resources. For this, we use the SymbioSpots framework. The Symbios POTS framework is an innovative approach developed by Engineering Faculty of Oporto and Cambridge University to assess industrial symbiosis, including logistical synergies, as well as mapping the waste. Its economical potential and the reduction of environmental impacts. It's intended to value the economical potential and the reduction of environmental impacts. It starts with mapping the donors, receivers, and routes. Mapping different layers of waste types, in this case, raw material, energy resources, and logistics. And validating it all with a triple win approach. The triple win formula guarantees that donors, receivers, and the planet all win with this symbiosis. It consists on building economical models that are real, prudent, detailed, and successful for all the companies involved. Also accounts the environmental impacts in detail, in this case, life cycle assessment. So, with the help of these tools, we set 2 new flows. For food, we develop a new line of breakfast cereals and granola that will be produced in Germany using germ and bran. Using a project finance approach, real and with real values, we guaranteed that the operation was economically viable and that the return on investment was also assured. The environmental analysis is also guaranteed, comparing with a typical breakfast cereal, as you can see in the graphs. In the feed, the new flow consists on making our company an hub for receiving the brand using the spare capacity on the return, and to develop a new line of feed pallets for livestock. Using also a project finance approach, we guaranteed that the operation was economically viable and that the return on investment was also assured for both donor and receiver. The environmental analysis is also guaranteed, comparing with a generic pellet. In short, we were able to reach the goals we proposed. German will start distributing a new product developed with this product as a form of breakfast cereal and a granola. The feed pellets are developed, and now we have to make the required investments to put it in action. The smart sensor is concluded, and all the goals in cooperation and synergy were reached. Thank you for your attention. I don't know if there are any questions.
If you have questions now.
I want to correct an information I gave earlier because of my English. The biggest vessel discharge wasn't 5,000 tons, it was 50,000 tons. It's one more zero.
It's very.
Can I make a question?
Yes, sure.
Well, congratulations for the presentation. It's really interesting. I am wondering if in all this process you found any commercial or regulatory barriers for these new circular products.
Yes. Our intention with this project was to use the silo powder to build the pellets. We did some tests, but and we can produce the pellets in our company. But right now, the Portuguese legislation doesn't allow us to wear the silo powder. So we are now starting a new project to see how the silo powder can be used, but right now it can't be used in the food and feed industry. We believe that in a very short period of time, the legislation will change in order so we can use a little part of this product as we intended in the first place. That was our biggest challenge. However, the wheat flour production generates about 20,000 tons of byproducts. We believe that that since they don't have any use, they go to animal feed. Since we found a very useful valorization for the humans, we believe that we'll start using more of this product in the food industry.
Excellent. Thank you very much.
I also have a question. Maybe I can add to the discussion. It's not really a question, but it's meant to share some thought. Maybe you can consider to explore other markets rather than food industry and feed industry that are very demanding in terms of legislation. Maybe other sectors are less demanding, like the construction sector and cement production as an alternative biofuel. Maybe can be something that you can consider in the future, which has a low barrier entry market for this byproduct.
Yes, right now we entered a new project. It's in the shoes industry that will incorporate this silo powder. It's a project. It's really starting.
Thank you.
But since it's a food product, we believe that it should be first used as food, because the population is increasing and we need all the food that we can use to feed everyone.
Thank you, Mr. Nuno Fernando, for excellent presentation. It was indeed a great perspective and fantastic example of a circular mindset.
Okay, thank you.
Thank you.
Have a nice conference.
Thank you. So, ladies and gentlemen, here we come to our first session on the topic natural resource. I remind you that this is the first of 4 sessions for which the speakers were selected by an abstract competition. Ours will be given to the best 3 works of the conference. I would like to invite Dr. Guilherme Ascensão to moderate this session. Before this, I would like to introduce Dr. Ascensão to you. Dr. Ascensão has a background in civil engineering with a degree by University of Évora and a master's by University of Aveiro. He has a PhD in material engineering by Keele Leuven and in environmental and civil engineering by the University of Padova. He's a researcher at the Unidade de Investigação Risco in the Universidade of Aveiro in civil engineering, and is a member of Smart Waste Young Professionals. So let's welcome again Dr. Ascensão. Guilherme, the floor is yours.
Thank you. Good morning, everyone. Thank you, Marta, for your kind introduction. It's always a pleasure to be part of this event and to be able to moderate this first session about natural resources, and which will have such great presenters. But before passing the floor to them, allow me a small word of gratitude to the audience that we have with us today and to the sponsors of this event by continuing to support this initiative, which I think is very important for us young researchers to see what other people are doing in the circular economy area, what problems they are facing, and which solutions they are developing. So without any further ado, I would like to welcome our first speaker of this panel, Francisca Casanova, whose presentation is entitled Sustainable Autohydrolysis and Bleaching Process for Cellulose Extraction from Sugarcane Byproducts. Francisca holds a master in biological engineering and a bachelor in bioengineering from the University of Porto. She has also some experience in working abroad in the University of Rai in Brussels, also in Vita Square, a biotechnological company in the Netherlands, and also in Nestlé, Portugal. She's currently doing a PhD in the same field of expertise in the Portuguese Catholic University. And before passing the floor to Francisca, I will also encourage the audience to post the questions in the chat during the presentation. And I will address to Francisca in the end of the presentation. Francisca, the floor is yours, and you have about 7 minutes.
Okay, thank you. Good morning. I will share my presentation. Okay, so good morning, everyone. My name is Francisca Casanova. I am a PhD student and lab assistant at the CBKF Associate Laboratory from the Catholic University of Portugal, and the work I'm presenting today is entitled Sustainable Autohydrolysis Processing for Cellulose Extraction from a Sugarcane Byproduct. This work was developed under the Alchemy Project, which is a joint collaboration between the Catholic University and the Amiris company, which aims to valorize byproducts and residues from the fermentation processes used by Amiris to produce their final products. In this project, the valorization activities have 3 main areas of focus. The first one is to valorize sugarcane straw, bagasse, and ash, which result from the sugarcane used as carbon source for the Amiris fermentation processes. As a second is to valorize the fermentation liquid veinous and bottom, and also to valorize the spent yeast. This project is of much relevance because it is based on circular economy. It addresses several societal challenges such as bio and circular economy, sustainable agriculture, and green industry. It takes a multidisciplinary approach, and it emerges from a unique partnership between Catholic University and Amiris, aiming for applied research and market-driven innovation. Sugarcane plantations are famous for their volumes and large amounts of residues, such as sugarcane bagasse, which is a promising, renewable, and low-cost raw material that currently is either burned or used for low-value applications, such as animal feed. Sugarcane bagasse has several components that can be valorized, but its major component is cellulose, which is present at 40 to 50%, and that can be used to produce value-added products for several applications. In lignocellulosic materials, such as sugarcane, the cellulose fibers are embedded in a matrix mainly composed of lignin and hemicellulose in a very tight manner, so effective methods are necessary to extract the cellulose. This work had the objective to valorize the byproduct sugarcane bagasse through the extraction of cellulose by a sustainable autohydrolysis process. The cellulose can then be used to various applications in value-added products. So, as materials and methods, the sugarcane bagasse supplied by the Amiris supplier Raizen was first pre-processed by drying, grinding in order to have a more effective extraction process, and sieving in order to remove inorganic substances such as dirt and ashes that may come with the bagasse from the field. Then cellulose extraction was performed by autohydrolysis using only water in a pressurized reactor for 1 hour at 3 different temperatures, 150, 170, and 190 degrees. The material was then filtered, washed repeatedly with water, and dried. The impact of the 3 different temperatures was evaluated regarding the process yield, the chemical profile, which was analyzed by NGEL, which determines carbohydrates and lignin in biomass, structural properties, and also we performed a sustainability analysis in order to assess if the process was indeed sustainable according to defined green metrics. Regarding the results, we can see here the chemical profiles of the several fractions. We can see that the sugarcane bagasse has a composition of about 45% of cellulose, 35% of hemicellulose, and 29% of lignin. All the extraction processes were able to increase the cellulose content and decrease the hemicellulose. The lignin compound was a bit harder to decrease, but even so, the temperature of 170 proved to be the most promising, producing a cellulose fraction with about 70% of cellulose. Regarding the yields, higher temperatures resulted in lower mass yields. However, until 170 degrees, no cellulose losses were seen in a considerable manner. So we have selected this temperature as the most promising for cellulose extraction. Regarding the structural characterization, the FTIR analysis showed typical cellulose functional groups, which the vibrations are indicated in the commercial cellulose sample in black. And these were detected for all extracted samples, and the vibrations related to lignin and hemicellulose, which are indicated in the bagasse sample in purple, either decreased or disappeared after the extraction processes. The X-ray diffraction pattern shows reflections that are typical to cellulose, which we can compare with the commercial cellulose sample. And the crystallinity increased considerably after extraction comparing to sugarcane bagasse, but with no differences between the 3 temperatures tested. The commercial cellulose has a higher crystallinity degree because this process has harsher processes and treatments. The same analysis of the untreated sugarcane bagasse fibers in figure 2A showed a compacted and agglomerated structure with a smooth surface representing the matrix of lignin and hemicellulose, but also the presence of other impurities such as pectins, oils, and waxes. After the extraction with autohydrolysis at 170 degrees, we can see that defibrillation and depolarization process occurred because we are able to see more separated and individualized cellulose fibers. Regarding the sustainability analysis, the green metrics assessed were the E factor, which is the waste generated per kilogram of product, the process mass intensity, which is the reactants used per kilogram of product, and the energy consumption per kilogram of product. For a process to be sustainable, these values should be as low as possible. In table 2, we can see the results for the autohydrolysis process at 170 degrees. The E factor was extremely low and below the typical values for the chemical industry, which indicate this is a more sustainable process. The PMI is a bit higher, but still acceptable considering that the only reactants that are used in the process are a byproduct, so inherently sustainable, and water, which can potentially be recycled and recovered. And so we have considered that this process is indeed sustainable.
Francisca, you have to conclude, okay?
Yeah, as conclusion, yeah, it is possible to extract cellulose from sugarcane bagasse via sustainable autohydrolysis process, producing a fraction with 70% of cellulose and 60% of crystallinity. If we want to achieve a purer and more crystalline cellulose fraction, maybe other treatments are necessary in addition, such as bleaching treatments that we are currently also studying as well. And that is it, some acknowledgements, and thank you for your attention.
Thank you, Francisca. Thank you very much for your comprehensive and very interesting presentation. I would like to pose you some questions from the audience, but maybe I will start with my own question to open the discussion. My question is that if you try to use this process or similar process to biomass sources that are more predominant in Portugal, like eucalyptus or acacia, that are also renewable and are more present in our territory.
We have not tried because our project is directed to the Amyris byproduct, which is mainly sugarcane. So we have tried with sugarcane bagasse and sugarcane straw. However, I think it could be interesting to apply this to other biomass sources, yes, and it could also produce promising results.
Okay. And the second part of my question is that I saw that you have a small amount of ashes, and not too big, but are you consider processes also to be truly circular to valorize this ash fraction that you get in the end, or this is something that is out of the scope of your project?
Well, we have also more quantities of ashes from Amyris, which they burn the sugarcane bagasse. So we also try to valorize these ashes, and we could also use the ashes from my process also to valorize. And we have some team members which are their work is based on the valorization of the ash in particular. So yes, that's also an interesting field to work on.
Okay. So thank you very much, Francisca.
Thank you.
Maybe we exceed a little bit of our time, so we will pass to the next presenter. I hope I can say the name right. The name right is Ash Ben Salah. Hello, good morning.
Hello.
Ashma is a graduate in biotechnology engineering from the Institute Polytechnic of Bragança and also from the private University of Tunis in Tunisia. She is executive member of several international organizations in this field and is currently working with Insulet, is a company, a medical company that develops new devices, innovative devices. And today she will present us a presentation with the title Application of Apple Cider Residue on Citric and Glycerol Bioprocessing using Aspergillus niger under solid state fermentation. The same goes for you, Ashma. You have about 7 minutes, and also for the audience, please post the questions in the chat room. The floor is yours, Ashma.
Okay, thank you very much. Please bear with me. Let me go ahead and share my screen. Okay. Are you able to see the screen?
Perfectly. You can start.
Okay, perfect. Then hello everyone. My name is Asma Ben Salhan, and today I'll have the honor to present to you my master thesis presentation entitled Application of Apple Cider Residue on Citric Acid and Glycerol Bioprocess using Aspergillus niger under solid state fermentation. Well, on the last decade, the apple cider industry have shown tremendous growth with the production of a low alcoholic beverage. But the making of such beverage is inducing apple cider residue, and it is inevitable. Actually, in Europe, it has been produced more than 0.35 million hectoliters of apple cider residue on a yearly basis. Its high biodegradability and high moisture content induce an uncontrollable fermentation, causing the production and the generation of 1,841 tons of CO2. So it doesn't only have environmental disruption, but also economical burdens due to the high cost of the treatments and transportation to dump the residue. So an introduction to such waste to the circular economy course of action is a must. How? Well, through the checking the ability of apple cider residue to be used as a solid substrate for glycerol, citric acid, or any other potential high value molecule to be used in other fields. Well, why? Well, both citric acid and glycerol are non-biodegradable, they are biodegradable, non-toxic, and they have acidifier, antioxidant, and antimicrobial properties. They are used in multiple fields such as dairy, pharmaceutical, cosmetics, etc. So first, we have started by a physicochemical and nutritional comparison in between apple cider residue and apple pomace, which is also a byproduct of the apple industries, and which has been under the scope of several studies for the past decades, and have been confirmed that it is a very competent byproduct for citric acid hyperproduction that reached up to 300 grams per kilogram. First, we have retrieved both of the residues, and we have dried them on hot air oven in 30 degrees Celsius for 72 hours. We sieved both of the byproducts into 1.72 millimeters particle. We diluted, filtrated, and injected through HPLC to retrieve the following nutritional table. As you can see here, apple cider residue have actually not as low sugar content as we have expected, since it is a fermentation byproduct. Compared to the apple pomace, we have also determined that it contained around 2.34 grams per kilogram of ethanol as a dry substrate that will be used in later on experiments. So the fermentation process was divided into three major experiments. First, we have prepared 140 grams of apple pomace, supplemented with different supplements, as you can see here, that were backed by several studies, in order to determine what the three best producing locally isolated Aspergillus niger strains. Once we have identified the three best citric acid producing strain, we have inoculated them in the second set of experiments, where we have prepared 90 grams of each of apple pomace plus supplements, apple cider residue plus the supplements, and apple cider residue with no supplements, in order to identify whether apple cider residue will compete in citric acid and glycerol production compared to apple pomace or not. And the result from this experiment, the best producing strain was later on inoculated in the third set of experiment, where we have prepared different concentrations, mixtures from apple pomace and apple cider residue, in order to study the effect of apple cider residue as a backup substrate in such mixtures that bring more sugar content and act as a natural inducer, since it does contain ethanol. Both of the three sets of experiments were held for 4 days at 30 degrees Celsius in an incubator. So moving on to the result, based on the second experiment, the MAM 92.13 have shown the highest citric acid production, which is around 14 grams per kilogram, but it did not actually exceed the production with the apple pomace with supplements by the same strain that reached 41.61 grams per kilogram. However, the production of glycerol on the apple cider residue with no supplements by the same strain have reached 53.61 gram per kilogram, which is even higher than when using apple pomace with supplements, with a yield of 0.93 gram per kilogram total sugar, which is a very interesting yield. These results were also pretty much the same with the final experiment, where we have where we can see here in both of the mixtures where citric acid production was actually induced into to 21.09 gram per kilogram, but it did not yet exceed the production with apple pomace that reached 32.33 with the natural inducer provided by the apple cider residue. However, a higher production of glycerol was induced within the mixture of 50% of both apple pomace and apple cider residue, with 61.51 grams per kilogram, and it had a higher yield of 2.19 gram per gram total sugar, which has also exceeded most of the yields resulted in other published studies. So with these results, we have concluded that the use of supplements with apple cider residue does have a significant positive effect on citric acid production, but it doesn't have, it does have a significant negative effect on glycerol production. And so on, we chose to do a microtoxin profiling in order to determine if our mediums, our prepared mediums, induces the production of mycotoxins or not. Well, actually, with a comparison with the yeast extract medium, with the inducive medium, we have found out that our both of the mediums, apple cider residue and apple supplemented and non-supplemented, actually do produce high-value byproducts such as pyranonigrine, which is a radical scavenging reagent rarely found in nature. Fonsesin and pyrophene have antimicrobial activities against Escherichia coli, Staphylococcus aureus, and Candida albicans. And actually, pyrophene, in a certain amount, in a certain concentration, have cytotoxic effect on breast cancer cells. And finally, kojic acid, which is a mide inhibitor for pigment formation in plants and animal tissues, and is an on-demand compound for its wide use in cosmetics and food, where it is a precursor of flavors enhancers, and in seafood to prevent color change. With these results, we have concluded that the use of apple cider residue as a solo substrate with no use of supplements seems to be more promising in glycerol production than citric acid production, bringing with that economical benefits resulting from the unnecessary addition of supplements and the use of non-sophisticated amount of equipment in such fermentation process. Further optimization can be done taking in consideration the produced beneficial byproducts throughout studying the corresponding production kinetics. And with that, I'd like to thank you for your attention. I would be more than happy to respond to your questions.
Thank you, Ajma. Thank you for your very interesting presentation and very interesting results, for sharing with us your research and your work. I will ask to the audience if there are any questions that you'd like to pose. If not, I will pose my own questions, since we are still early in the morning and we are not getting very questions, and your presentation was quite clear. So I think the results are very interesting. It's not my field of expertise, but I think it's very positive results, and it seems a very consolidated research. So my question is that you are in which phase you are from passing from the lab to the industry, if there are any semi-industrial tests, in which point of development are you, or if it's just a more science-based project, or if it's more industrially oriented and you have already products almost ready to go to the market. I would like to know a little bit more on the stage of development of your research project.
Mm-hmm. Well, till this day, it's still a scientifically based project, but I am doing some, let's say, side work regarding this type of project because it will need sponsoring. And in the first phase, the results are really interesting. But what we need right now is the retrievement of the glycerol and see the yield of the extraction and the purification of the product. I have been doing some research to implement such project back home. But right now I'm actually searching for investments right here to be able to continue to develop this project and to make a startup out of it.
Well, maybe this conference can be a good platform for
yes,
raising interest and sparkling some interest on your audience, and maybe we can be the bridge between you and your future sponsor for continuing your project. Thank you, Ashma. Thank you for sharing your research, and thank you for the presentation. Next, we will follow with Ana Carolina Casoni, which unfortunately cannot be with us today, but she provided us with a recorded presentation. So we will show the presentation that was previously recorded by Ana Carolina. She holds a bachelor in biology and a master's degree in ecology, environment, and territory from the Faculty of Sciences from the University of Porto. She is participating in several research projects in the last years on the development of sustainable textiles from bioresidues. And she is now currently pursuing a PhD in the same field of biotechnology. His presentation today is entitled Extraction of Lignin from Agro-Food Residues using deep eutectic solvents. I think someone will help me to put
I will share it.
Okay.
I hope that it goes well. So let me know if you can hear it and see it.
Hi, I'm Carolina Cassoni, and I'm a PhD student at Catholic University of Portugal. Today, I will be presenting my work entitled Extraction of Lignin from Agro-Food Residues using deep eutectic solvents. The agro-food industry generates large amounts of wastes with lignocellulosic nature that can have great value. The lignocellulosic residues are composed by cellulose, hemicellulose, and lignin, and while the carbohydrate fractions are well studied, lignin is still underappreciated. Nonetheless, lignin is a biopolymer that has several applications, namely in the agro-food industry, due to its bioactive properties such as antioxidant and antimicrobial capacities. Besides the various applications, there are also several possible extraction methods, and the more classical methods are, for example, the Kraft, Soda, Organosolv, and in fact some of which are already implemented at an industrial level. The deep eutectic solvents appear as a more environmentally friendly alternative to the classic methods and is still much less studied, although there has been an increasing research effort in the last few years. Thus, this work proposes the recovery of lignin from different agro-food residues, grape stalks, brewer's spent grain, olive tree pruning, using the deep eutectic solvent. In this study, we used lactic acid choline chloride, which is a more commonly used deep eutectic solvent. We began the lignin extraction process by carrying experimental design. The chosen design was a 2-cube factorial design with 3 levels and 2 independent factors, temperature and time. The evaluated responses were lignin yield and antioxidant activity through ABTS and DPPH assays. According to the experimental designs, the optimized conditions to extract lignin from all the residues were defined as 100 120 degrees Celsius and 5 hours. So, using these optimized conditions, we performed an experiment to validate the data. For the grape stalks, we can see that the obtained results was slightly lower than the values predicted, but nonetheless very close. For the olive tree pruning, the lignin yield was also lower, but the antioxidant activity was somewhat higher than predicted. BSG had a lignin yield according to the predicted values, but with also slightly higher antioxidant activity. Upon the optimization, lignin samples were characterized regarding purity, structure, and total phenolic content. Performing the extraction with hypothetic solvents allowed a lignin recovery with high purity, especially for grape stalks which had 90% purity. Regarding the structure, analysis by FTIR showed that all the samples present lignin typical bands, and we can see that the spectra is similar for all the residues. We also performed some analysis to visualize the lignin morphology, and all the lignin samples had a polyhedral shape with a relatively uniform surface, and we can see that olive tree pruning had the smoothest surface. Some elongated structures can be observed on the BSG sample that may correspond to the carbohydrate impurities. As for total phenolic content, we can see that grape stalks have the highest value, being more than 3 times higher than BSG. In addition, we performed a comparison of antioxidant activity with a commercial antioxidant. For ABTS, although grape stalks and olive tree pruning samples have high antioxidant activities, they are much lower than the reference BHC. But for DPPH, both grape stalks and olive tree prunings present a higher antioxidant activity than the commercial antioxidant, showing that these lignins have indeed a high antioxidant capacity. Summarizing the results, grape stalks and BSG present the highest yields, and grape stalks also has the highest purity. All the lignins have the typical bands on FTIR and present the polyhedral shape. But we can see that the BSG has less aromatic related peaks, and we also seen the elongated structures on the morphology. The biggest difference between the lignins is the total phenolic content and antioxidant activity, where grape stalks is the lignin with most potential. In conclusion, we can say that hypothetic solvents is a sustainable, environmental friendly and effective method to extract lignin from grape stalks, olive tree pruning, and brewer spent grain. And the agro-food residues are valuable biomasses for the recovery and valorization of lignin, contributing to sustainability in circular economy. Thank you so much for your attention.
So unfortunately, we will not have the opportunity to make some questions to Anna Carolina. It was a very interesting presentation, however, and I would like to thank Carolina for that and for her work, which was very interesting, and for sharing our results here today instead of not be possible to attend the meeting. I would like also to highlight that lean and bio-based projects are being very predominant in this session, which shows well the importance of developing new products from this from agro-food and forestry byproducts. And in the same line, we will have the last presenter of this first session, which is Daniela Magalhães. from the Portuguese Catholic University. Daniela is a bachelor in biotechnology and has a master in food safety from the University of Coimbra. And she's now working, she has also been working abroad in France and is currently pursuing his PhD in biotechnology as well. Today, she will present us her work on lemon byproducts with the title Lemon Byproducts Valorization, a Circular Economy Perspective. You are fortunate, Daniela, you have a little bit more time than expected, so you can provide us with more details on your research, and I will be eager to know more about your presentation and your work. The floor is yours, Daniela, when you can. We already seen your presentation.
Okay, thank you so much.
But you need to put on
yes. Are you okay now?
Now it's perfect.
Okay. So good morning, everyone. My name is Daniela Magalhães. I'm a PhD student at Faculty of Biotechnology in Porto, and also I'm a researcher of MediSmart project. Today, I will talk about valorization of lemon peels using a circular economy perspective. So this presentation will be divided in 4 parts. Introduction about circular economy and lemon peels valorization, the objectives of my PhD work, the experimental assays and the first results, and I will finish with the main conclusions. So, the genus citrus produces one of the most common consumed fruits worldwide. Its annual production represents about 120 million tons per year, where lemon and limes represent around 16 million tons. This high production generates a huge amount of losses and waste, like peels, pulps, and seeds. And these wastes represent more than 50% of the whole fruit. In my PhD work, I will valorize lemon peels from a Portuguese company called Frutas 13, and this company produces lemon wastes around 14.2% per year, which represents 49,000 kilograms per year. So it's extremely important to valorize this byproduct contributing for circular economy. So lemon peels are subdivided in 2 parts. The yellow part called flavedo, which contains flavonoids, phenolic acids, carotenoids, and essential oils, and the white part called albedo, which contains dietary fibers, and can be divided in soluble, include pectin, and insoluble, include cellulose, hemicellulose, and lignin. These bioactive compounds have a wide range of bioactive properties, including antimicrobial and antioxidant activity. So for this reason, the main objective of my PhD work is develop a sustainable integrative approach to valorize these lemon peels, which are very rich in bioactive compounds like polyphenols, essential oils, and fibers, to develop natural antioxidant and antimicrobial solutions and apply these solutions to food models. Now, I will present the experimental assays that I have been realized and my first results. So, for all experiments, I used lemon peels from Algarve and Eureka variety. So, in order to understand the potential valorization of lemon peels, it is important to perform the nutritional characterization, and the results showed a high concentration of carbohydrates, including a relevant content of dietary fiber, which represents 41.16 grams per 100 grams of sample. The second experimental assay that I have been realized is about polyphenols, identification and quantification, and antioxidant activity. So, polyphenols was extracted with a range of 8,2-methanol water and analyzed by HPLC. So, lemon peels showed a polyphenol content of 2.30 milligrams per gram, and had a good scavenging effect on DDPH and ABTS radicals. The major polyphenols found in lemon peels were eriocitrin and expiridine. In order to recover essential oils, compounds considered as natural antimicrobials, I realized the last experimental assay for identification of volatile compounds. So, essential oils were obtained by hydrodistillation in a Clevenger apparatus and analyzed by GC-MES. So, the results showed the presence of 24 compounds representing 98% of the total area. The compound D-limonene was the major constituent, represent 59%, followed by pinene and terpene. Here, my main conclusions, and according to these results, it can be concluded that lemon peels byproducts contain interesting compounds, mainly fiber, phenolic compounds, and essential oils, and their concentrations are significant, justifying their valorization in different food applications, contributing to the circular economy and sustainable perspectives. So we start with a problem, lemon industry waste. We need to create solutions for this problem. In my case, is lemon peel fractions rich in bioactive compounds. The solutions, these lemon peel fractions will be applied in preservative coatings and fiber-based powder fractions. And after that, I will apply these solutions to food models. So, for conclude, this is circular economy, and I will make it happen. Also, I would like to thank FCT for my individual PhD grant, to CBKF and MediSmart project. And I would like to thank Frutas 13 company for offering lemon samples for analysis during my PhD work. And thank you so much, everyone, for your attention.
Thank you, Daniela. A truly circular example from the food industry to the food industry. Is very interesting to see this end-to-end from the starting of the food production to the consumer and then recirculated again. It's very interesting to see that you are thinking about the whole lemon peel food chain. I will invite again our audience to pose some questions. We still have a couple of minutes to discuss this. I will ask to all to not be shy and to pose you some questions. Otherwise, I would like to have a comment in the meantime while people are typing. I think it's very interesting that you are particularly focused on lemon peels because it's a very important industry for the Algarve region, which is very the most important economic activity is tourism, as we all know, and this added value products for a traditional crop can be very useful to diversify the economy and to give some resiliences that is now talked in everyday journals to the local economy and also to the economy and national level for this and for other bio-derived products that we saw this morning, from lemon peels to cellulose fibers from other bio-waste products. And I think this is a very interesting topic in general, and your work in particular is very actual and pertinent for the Algarve region. We didn't hear you, but I think
thank you so much. Can you hear?
Yeah. Now we can hear. The same goes for the that I asked to the previous presenter. It goes for you, if that you focus in this particular crop because it's a very important crop, but maybe other citrus crop can be processed in the same way. And I guess you are looking at that. Maybe you can give us some details on your other projects that I know that you have.
So I am a researcher of MediSmart project, and this project are European project with partners from Turkey, Egypt, Spain, and Italy. And from Portugal, we work with lemons and also with oranges. And the next panel, we will have the other girl that work in the MediSmart project with orange peels.
Okay.
So in this project, we work with orange, mandarin, lemon, and with another citrus.
Okay, so you cover all the citrus that
Yes,
we
yes.
know better in Portugal.
Yes.
Okay, thank you. I think we don't have questions for now. No, we have a question.
Okay.
We have
Can
a question.
I write after in the chat?
I will pose the questions so people can. I think the question is from Maria João Valle. Maybe Maria João Valle wants to intervene, but if he can, I will pose the question. So Maria João is asking that lemon flavor is widely used, and she asking if it will be possible to recover it at some point, the aromas for later application in flavor. So I think she is saying that this lemon is as a such sweet taste. So she's asking if you can recover the aroma and introduce the volatile compounds in other preservatives, in other foods.
Yes, I suppose, include the essential oils. In my last application, I will put essential oils in coatings and apply these coatings in fruits. And I will suppose the flavor are not missing.
Okay, so flavor will not be transferred to the foods. Okay, so we are receiving now more questions from Ezekiel. I think Ezekiel can introduce itself and put your question. Ezekiel, can you hear us? No, maybe not. Maybe
yes,
not.
yes, maybe yes. Hello?
Hello, Ezekiel.
Yeah, I congratulate Daniela because it's a very interesting presentation, and the work is almost in our area, our field of work in UCP. But I want to Daniela think about the future and how she see this kind of approach, and how she see in Portugal in particular this kind of approach in other crops or other byproducts.
I think it's possible apply this in Portugal, but also in my case, I have an opportunity in other countries in Europe. So I think I can start with Portugal and see if it results. And if not, I will try in Spain or Italy. I don't know.
Okay. Thank you, Daniela. Thank you, Ezekiel.
Thank you.
Very interesting.
Thank you so much.
I think that the bottom line, the industry is receptive to this new kind of products, and we will have a bright future in this field of new bioderivative products. I would like to close this session by thank you to all the presenters for their work and for their presentations that were really very interesting in highlighting for the others. Unfortunately, we didn't have Ana Carolina with us, but I will thank her personally for his presentation as well. And now I will close this first session and pass the word again to Marta, so you can introduce the next panel and the next topic of this conference. Thank you all.
Thank you, Guilherme and speakers, for this insightful session. As Guilherme said, we have a short break. after that, we will continue with our sessions, including health benefits with Mr. João Graça and little case study with Mariana Diniz. So stay with us. We come back at 11 o'clock. Hello, everyone. If you have just joined with us, this is the second 4 sessions for which an abstract competition selects the speakers. Awards will be given to the best 3 works. I would like to invite my colleague, Mr. João Graça, to moderate this session. Before this, I would like to introduce Mr. Graça to you. João Graça is a project manager at the innovation team of LIPOR, where he works on topics related of bio-waste valorization. João has an academic background in the area of bioscience, including a PhD by Cardiff University. Let's welcome again, Mr. Graça. So, João, the floor is yours.
Thank you, Marta. It's a pleasure for me to moderate this session. So the healthcare market is the ultimate evidence of the viability of the circular economy model. If what was once a waste can be used to improve our well-being, then what is the limit for what we can do with waste? It is therefore my pleasure to introduce the first speaker of this panel, Jessica Santinha Almeida. Jessica is a master's student of molecular genetics at the University of Minho. She's developing a master dissertation at the Center of Molecular and Environmental Biology with the aim of obtaining plant extracts with antioxidant activity and neuroprotective properties. Before giving the floor to Jessica, I remind the participants that they can place questions to the speakers using the chat. So Jessica, the floor is yours.
Good morning, thank you so much. Are you seeing my screen?
Yes. All okay.
So good morning, everyone. First of all, thank you so much for the opportunity to be here today presenting my work. My name is Jessica Almeida, and I'm going to talk about the work that I've been developing in the scope of my master's thesis at University of Minho regarding the potential health benefits of a unique citrus species called Citrus australasica. Well, firstly, I would like to explain and talk about how inflammation and oxidative stress are related to several diseases. So the inflammatory response in general is a great defense mechanism of our body. An injury or infection happens to our body, and immediately the activation of pro-inflammatory transcription factors take place, leading to increased expression of pro-inflammatory cytokines, chemokines, and other inflammatory mediators. Subsequently, more immune system cells are activated and recruited to the injury site. And these several mechanisms work in a coordinated way to consent to the proper inflammatory resolution by producing bactericidal chemicals, including reactive oxygen species and reactive nitrogen species, in order to eliminate the pathological event and also eliminate dead cells and tissue debris. After the resolution of the inflammatory event, the cells can eventually return to a resting state. So in summary, inflammation should be a rapid, intense response aimed to tissue protection and recovery, and should be highly controlled to avoid detrimental consequences. However, exogenous stressors such as pollution, smoking, a fat diet, or endogenous factors like diseases, mitochondrial dysfunction, and inflammation itself are potentially able to disrupt this finely tuned homeostasis, inducing the production of really high fluxes of reactive oxygen species and reactive nitrogen species. And in return, these reactive species can act as signaling molecules and can also activate the inflammatory transcription factors and therefore augment the inflammatory response. And this mutual activation between inflammatory and oxidative stress mediators interacts in a positive feedback manner. And this self-feeding loop in the long run can induce or aggravate pathological dysfunctions such as neurodegenerative diseases, cancer, cardiovascular diseases, diabetes, among others. So although the human body has natural antioxidant defense mechanisms to face oxidative stress, and although these are quite effective, In some cases, in some disease scenarios, in some cases, they are not enough and can also be incomplete because the human body cannot produce some important antioxidants, which must be supplied by diet. In this context, citrus fruits are generally really rich in bioactive compounds like phenolic compounds, which exhibit a wide range of pharmaceutical properties, namely antioxidant, anti-tumor effects, anti-inflammatory actions, weight control, and blood glucose regulation activities. In this context, the main goal of my work is to evaluate the antioxidant capacity of a unique citrus species called Citrus australasica and commonly known as finger lime or caviar lime. Citrus australasica is one of the 6 citrus species endemic to Australia. The fruit is cylindrical with variable coloration due to the genetic diversity of the species, ranging from black or brown, yellow, green, or pink. And one of the most unique features of these fruits is the ovoid or spherical pulp vesicles, giving the pulp a caviar-like appearance, as we can see in this image. So regarding my work, I'm working with 2 varieties of caviar lime, a green, a pink one, that were cultivated in Portugal in the Minho region. And the peel of these limes were removed, lyophilized, grinded, and extracted with 80% methanol. And after the solvents were evaporated, the resultant extracts were submitted to several antioxidant activity assays, including DPPH, ABTS, FRAP, superoxide anion, and nitric oxide. Results show that both extracts exerted antioxidant activity in almost all the assays. DPPH and ABTS are antioxidant methods based on electron transfer, and FRAP measures the ability of the extracts to reduce iron 3 to iron 2. And the superoxide anion and nitric oxide assays measure the direct scavenging of free radicals, which in other words means that the ability of the extracts to chemically neutralize superoxide radicals that are reactive oxygen species and nitric oxide radicals that are reactive nitrogen species. So these results are pretty relevant because they show the potential of these extracts in preventing oxidative stress. Nonetheless, these are biochemical assays and they are not enough to make a complete antioxidant characterization. Thus, assays in cellular models are being conducted in order to corroborate these results. Moreover, the phytochemical profile of both extracts is currently under study. High-performance liquid chromatography was used to evaluate the phenolic profile of the extracts. And so far, we were able to identify several bioactive compounds of phenolic acids and flavonoids, such as chlorogenic acids, caffeoalkenic acids, quercetins, procyanidins, catechins, among others. So to the best of our knowledge, little published information is available about caviar lime. Thus, the study of its phytochemical profile and the complete characterization of the antioxidant potential of the extracts is extremely relevant for the valorization of this species and can also support its inclusion in the food, cosmetic, and pharmaceutical industries. Thank you so much for the attention.
Thank you very much for your excellent presentation.
Thank you.
If anyone wants to pose a question, I would welcome them to write on the chat or to speak up. Before I will make my own question, which is I'm wondering from a presentation, how can this work have a practical impact on circular economy? So are there any sources of finger lime that can be used as antioxidants, or can it any waste sources, I mean, or is there is it substituting something that is more a limited resource? How?
Well, for instance, we are studying the peel of the fruits, not the pulp. And currently, these limes are widely used in culinary, like really fancy culinary. So the pill is really not relevant for the wider applications, and it has been explored for its bioactivities. And in that way, I believe that it can contribute for that purpose. Yes. I don't know if I answered the question.
No, yes, definitely. I'm not seeing any other questions. So if no one else has a question, I would like to thank you once again.
Thank you so much.
And I will now introduce our second speaker of this panel, Cristiana Breda. Cristiana has a PhD in Chemical and Biological Sciences from the University of Trás-os-Montes e Alto Douro. She has also a master's in food engineering and a bachelor's in agronomic engineering from the same university. She's a published author with experience in the chemical characterization of different food matrices. So, Cristiana, the floor is yours.
Thank you. Good morning. My name is Cristiana Breda. First, I would like... Good morning. My name is Cristiana Breda. First, I would like to thank the organization for the opportunity to present my work. My research is focused on chemical study of craft beers and their byproducts. In this presentation, I will talk about bioactive compounds from byproducts of craft beers, characterization and potential applications. My presentation is divided in 5 topics: introduction, objectives, material and methods, results and discussion, and conclusions. Despite the concept of craft beer was introduced in the beer industry recently, it has been growing very quickly, although there is no exact definition. A beer is considered a craft beer when it is produced using traditional practices and using traditional or innovative raw materials. In general, the main raw materials used in the beer production are water, malt, hops, yeasts, but other unconventional raw materials can be added, such as fruits or spice. The production of these beers generates large quantities of byproducts, such as spent grains and spent hops, which to date present a low commercial value. These byproducts can be used for microalgae production, biofuel production, phenolic compounds extraction, antioxidant substance, among others. Therefore, the main goal of this study was to determine the phenolic composition and antioxidant capacity of Portuguese craft beers and their byproducts. For that, the sampling was constituted by 24 craft beers and 2 different byproducts, namely spent grains and spent hops. For each type of craft beers and byproducts, the goal was to evaluate its phenolic composition and antioxidant capacity. In this sense, we performed determination of total phenolic or todiphenyls and flavonoid contents. Furthermore, an accurate quantitative and qualitative determination of phenolic compounds by HPLC was performed for the craft beers. Regarding the material and methods, the samples were analyzed through colorimetric assays, namely total phenols or todiphenyls and flavonoids. The determination of antioxidant capacity was performed using ABTS and DBPH methodologies, and all the samples were analyzed in triplicate. As previously referred, the evaluation of individual phenolic compounds of craft beer was carried out by HPLC. Concerning the results, it can be observed that craft beers show a significant difference in content of phenolic compounds and the antioxidant capacity. Sample 19 showed to be the one with the highest concentration in total phenolic or todiphenyls and flavonoids contents. In this case of the antioxidant capacity, once again, sample 19 present the highest activity in both methodologies, ABTS and DPPH. Regarding the quantification of phenolic compounds by HPLC, gallic acid and catechin were the compounds that were present in almost all the beers and had high concentrations. Analyzing the results of byproducts and concerning total phenols, it was possible to observe that spent hops demonstrate the highest concentration, being significantly different from spent grains. Regarding the content of orthodiphenols, once again, spent hops proved to be the sample with the highest concentration, being significantly different from the other byproducts. From the results of flavonoid content, it was possible to observe that spent hops present the highest concentration, as verified in total phenols and orthodiphenols. The antioxidant capacity of craft beer's byproducts has also been determined by two methods, ABTS and DPPH. Concerning the ABTS method, and as expected, the results demonstrate that spent hops were the sample with the highest antioxidant capacity, significantly different from the other study sample. Regarding the DPPH methodology, as it happened for the ABTS method, spent hops were again the sample with the highest antioxidant capacity, being significantly different from the other sample. Therefore, with this study, we can conclude that the different range of phenolic profiles and antioxidant capacities obtained in craft beer are essentially caused by the different raw materials and brewing process used in their production. In fact, it was possible to observe that sample 19 present the highest concentration in total phenols, orthodiphenols, and flavonoids, as well highest antioxidant capacity for ABTS and DPPH methods. It was also possible to verify that this sample presents the highest concentration of individual phenolic compounds, namely gallic acid and catechin. Furthermore, it is well known that craft beer includes the production of different byproducts such as spent grains and spent hops. The results obtained in this study indicate that byproducts from craft beers, namely spent hops, are a rich source of phytochemicals. Thus, this byproduct can represent a sustainable and good alternative for recovery of bioactive compounds and could be significantly useful in cosmetic, pharmaceutical, and food industries. Thank you for your attention.
Thank you very much for the excellent presentation. Well, I'll start with a question and hope that we get some more from the audience. So I'm wondering if how can this research that you presented be scaled to a commercial model? So what kind of companies would implement this kind of methodologies? Would it be directly the beer companies? The variability would, or would it be other kinds of companies that would receive material from different breweries? What would be the
First, we start with craft beers is a different type of beer, and for now it's just in the craft beers. We analyze the byproducts, and in this moment we analyze different byproducts of different craft beers. In the future, maybe I analyze byproducts of big companies.
Okay, excellent.
I can do a third question. I don't know, João.
Go ahead, Marta.
Thank you for your presentation, Cristiana. So you can use directly your byproducts, or you need to do something. So if you have an enterprise, you use directly?
Yes, I use direct byproducts.
Yes, okay. Thank you.
Excellent. Anyone else has question? So if not, I'd like to thank you very much.
Thank you.
And I will pass on to the next speaker. I will introduce our third speaker of the panel, which is Rui Dias Costa. So Rui is a PhD student at the Chemical and Biological Sciences at the University of Trás-os-Montes e Alto Douro. In his PhD, Rui is studying the valorization of wine byproducts for the pharmaceutical and cosmetic purposes. Prior to the PhD, Rui has participated as a fellow in 2 different research projects involving the characterization of bacteria and yeasts and also the chemical characterization of food matrices. So, Rui, the floor is yours.
Hello.
Hi. I can hear you now, but the presentation is not in full screen. Okay, all good. Ready to go.
Thank you. Good morning. My name is Rui Costa. In this presentation, I will talk about phenolic composition and the antioxidant capacity of grape pomace and stems from the Douro region. I would like to thank the organization for allowing me to do this presentation. This presentation is divided into introduction, objectives, material and methods, results, and conclusions. After being pressed, the grapes are used to produce wine originating byproducts such as stems and pomace, which are rich in bioactive compounds. These wastes can be reused and originate products with potential applications in food, cosmetic and pharmaceutical industries, and thus contribute to the circular economy. The wastes resulting from the wine production are designated winery byproducts. Those are constituted by vine shoots, grape pomace, grape stems, and wine lees. Grape pomace is winery waste originated during the production of must by pressing whole grapes. These wastes correspond to approximately 10 to 30% of pressed grape mass and is composed by skin, seeds, and residual stems after the grapes are pressed and fermented. Grape stems correspond to almost 25% of the total products resulting from the winemaking and grape production process. The objectives of this work were determination of phenolic compounds of grape pomace and stems, as well as the antioxidant capacity. To achieve these goals, the samples of grape pomace and stems were collected in the Douro region and freeze-dried. Then, the phenolics were extracted, and finally, the spectrophotometric analysis was performed to determine the content of phenolics, total phenols, orthophenols, and flavonoids, and the antioxidant capacity by ABTS, BPPH, and PrEP methods. The grape stems samples are constituted by 3 white varieties and 3 red varieties. Concerning the sampling of the white varieties, pomace, this is composed by 2 mixtures, one from Simacor region and the other from Baixcor region. In the case of the red varieties, it was constituted by a mixture from Douro Superior. Regarding grape pomace, the white varieties from Simacor region showed higher values of phenolic compounds and antioxidant capacity than the white varieties from Baixcor region, and these differences are significant except for the antioxidant capacity using the ABTS methods. The red varieties from the Douro Superior region show lower values of phenolic compounds and antioxidant capacity than Simacor varieties except for the antioxidant capacity using the ABTS methods. There are significant differences between all the study samples in what concerns to PrEP and BPPH methods. Concerning the grape stems of the white varieties, the Verdejo sample was the one that presented the highest values of phenolic compounds, being significantly different from the Fogazan sample in terms of orthophenols and total phenols content, and significantly different from samples focused on codoglutarine in flavonoids content. Regarding the antioxidant capacity, the Verdel sample was a variety that presented the highest levels of antioxidant capacity, being significantly different from the other white varieties using the FRAP and the BTS methods. Concerning the red varieties, Tinta Barroca showed the highest values of phenolic compounds. Those values are only significantly higher than those obtained in the case of orthophenols and flavonoids for Toriga franca. Regarding the antioxidant capacity, the varieties Tinta Barroca and Tinta Boris are the ones with highest values, not different significantly from each other. After the assessment of the parameters addressed before, the correlations between them were performed in the case of SWYP stem samples. Resorting to Pearson coefficient correlation, significant positive correlations were obtained between FRAP and total phenols content and flavonoids content, namely 79% and 94% respectively. Also, a significant positive correlation was obtained between ABTS and content of flavonoids, namely 91%. It was possible to conclude that the web stem samples used in this study show a higher content of orthophenols, total phenols, and flavonoids compared with the web palm samples. There are higher values of antioxidant capacity in web stems compared with web palm samples. Of the several byproduct studies, the web stems revealed to be the one with the best phenolic composition and biological properties. These are preliminary results of my PhD, which started only this year. Thank you for your attention.
Thank you very much for your very interesting presentation. I will open again the floor for questions, and I will start with my own. What are the next steps that you have thought for this research? How can it be presented and applied to the industry with the views of scaling it up?
Okay, in the next phase, I will optimize the extraction methodologies of bioactive compounds. I will study other byproducts, vine shoots and wine leaves, and I will study antimicrobial activity, anti-aging, anti-inflammatory, and other biological properties.
Excellent, thank you.
Well, I can do a question, Marta.
Yeah, go ahead.
Thank you very much, Rui, for your presentation. It's a nice presentation. I have only one question for you. Based on your results, what is the variety that you have that you think that you can contribute for the circular economy? Because it's the basis of this conference. So,
Verdelho variety and Tinta Barroca and Tinta Barroca.
And why? Do you have an application? Do you have think about this?
Because these varieties, these results have high levels of orthophenols, orthophenols, and flavonoids, and antioxidant capacity.
Okay.
By free methodologies.
Okay, thank you very much.
Wow.
Again, nice day.
Okay, excellent. Thank you very much. Anyone else wants to make a question, comment? So if not, thank you very much. And I will move on now to the next speaker of our panel. Our fourth speaker will be Sara Cunha. Before I introduce Sara, I remind the participants to, and I ask them to, if they wish, they can make the questions either in the chat or in the or talking in this time dedicated to Q&A. So Sara is biotechnology PhD student at the Catholic University of Portugal. Her research has the main goal of developing natural and sustainable bioactive ingredients from marine sources with commercial potential for the development of functional food or anti-aging cosmetics. We already had the pleasure of having Sara in the first edition of our conference last year, and we are really looking forward to see her new work that will be presented. So Sara, the floor is yours.
Is already on the presentation?
Yes.
Okay.
All good.
Thank you. So good morning, everyone. My name is Sara Cunha. I'm a PhD student at Universidade Católica Portuguesa, and the work I bring here today focuses on the valorization of muscle meat waste as a source of bioactive ingredients for industrial application. Methyllus galoprovincialis is a muscle highly consumed worldwide, with Europe being the major continent with the higher production. Mussels have sustainable farming, since it can be done with minimal greenhouse gas emissions, thus low carbon footprint. For the consumers, mussels have low fat, low calorie, are a great source of sodium, selenium, vitamin B12, and also a very good source of proteins. However, when we want to commercialize mussels, they need to fulfill the market criteria. So, before being delivered for sale, mussels need to be pre-selected according to the needs and the requirements of the target market. Consequently, broken mussels or mussels with size out of the established criteria are discarded. So we are generating waste, which corresponds to about 27% of the total mussel production. Since mussels are a great protein source, they can be used to produce bioactive peptides that can have potential for several industrial applications. But how can industries benefit from these compounds? One example is the cosmetic industry that can use antioxidant muscle peptides as an ingredient to reduce the generation of radical oxygen species in the skin, or at least to decrease the damage caused by them. So they can be used in formulations for anti-aging. This way, it can be in line with the cosmetic trends of a natural and a sustainable beauty. Another example is the food industry. For that, the bioactive hydrolysates may be interesting since they may be easily absorbed by the gastrointestinal tract when compared to the intact proteins. They can be used to produce functional foods with benefits for human health. They can also be used as food preservative, thus contributing to a sustainable development. Therefore, this work main goal was to develop a sustainable methodology that allows to transform muscle meat waste into water-soluble extracts rich in proteins, bioactive peptides, and also able to resist to the gastrointestinal digestion. For that, we have used discarded mussels and we have submitted them to an enzymatic hydrolysis with a subtilisine protease. We have optimized this methodology to produce two interesting ingredients. The one that I'm presenting here is the water-soluble fraction, the one with the bioactive properties. However, it's important to say that the other fraction still has a very interesting nutritional profile, so it can be used for commercialization, for example, as an ingredient for animal feed. So, in addition to being a food grade and a sustainable process, it is important to refer that it leads to very low waste production because we produce two fractions with very interesting commercial potential. But now, talking about our main ingredient, the soluble fraction, it was studied regarding several properties, and we found it to have a really interesting protein content with around 45% of protein. Regarding the bioactivities, this ingredient did not show a really high anti-hypertensive potential, and in terms of antimicrobial potential, it was able to decrease the growth of few bacterial strains. However, it did not entirely inhibit their growth. So right now we are studying an ultrafiltration process to see if we can improve these bioactivities, because both are associated with peptides with smaller molecular sizes. But our most promising results were observed in ORAC, which revealed a high antioxidant potential, but also in the ability to inhibit alpha-glucosidase enzyme, which reveals a really interesting anti-diabetic potential. However, if we want to create nutraceuticals or functional foods with these ingredients, we need to guarantee that their bioactivities are maintained after ingestion. In other words, these ingredients should not be destroyed by our gastrointestinal tract. So, to understand in vitro the behavior of the ingredient after ingestion, we have submitted them to a simulation of the gastrointestinal tract with conditions similar to those found in the human digestive system. In each digestion step, we have collected samples which were evaluated for their antioxidant potential using ORAC and ABTS assays. We have observed that the antioxidant activity was maintained after all digestion phases, and this result is really important because it confirms the high potential of the hydrolysates to be used as a bioactive ingredient for the production of So, in this work, it was intended to give a regenerative approach to discarded muscles by transforming their meat into high-value hydrolysates that can be commercialized as functional ingredients for food, cosmetic, and nutraceutical industries. And we believe that this ingredient may be easily commercialized since the functional ingredients market has been constantly increasing. And so, as a conclusion, with the presented methodology, we can produce natural and sustainable value-added ingredients for commercial purposes, aligned with the industrial and consumer trends, while valorizing muscle waste in a circular economy context. So thank you all for the attention, and I will be glad to answer all of your questions.
Okay. Excellent. Thank you very much. I think Ezequiel has a question.
Yes. Thank you very much, Sarah. And I have a question. If you already think about a prototype to apply it to, if you can analyze that all the bioactivities remains in a prototype, and it's if it is a form to a way to show the applicability of this kind of ingredients.
Thank you for the question. First, I will tell you that we actually have started testing these ingredients. In a previous project, I was working in Valormar, and we have worked along EPVC by testing them as ingredients in horse mackerel, the fish. And we saw that when using these ingredients into the fish, it has functional properties that can be useful for human health. Right now, what I'm working in is developing a prototype for cosmetic applications. I have a few more results now, more focused on the cosmetic field. And I'll be doing a formulation with these ingredients.
Thank you very much.
Okay. Thank you. Excellent. Are there any other questions? Meanwhile, I can make one. Are there any, or is there any pretreatment that is needed in your method to, I don't know, eventually remove sands, shells, or other more gross contaminants before making this hydrolysate?
Actually, we separate fractions in the beginning of the process because we are just working with the meat. Yes, we separate the shells and then we clean with abundant water the meat, and that's it. And then we start the process.
Okay. Excellent. Any other questions? So if not, I would like to thank you again for your brilliant presentation and move on to the next speaker. So our fifth speaker of this panel is Irene Govinhas. Irene is a researcher and an integrated member of CITAB and the Associate Laboratory Innov4Agro. She has a PhD in Chemical and Biological Sciences from the University of Trás-os-Montes and Alto Douro. Irene is a widely published author with remarkable experience in the study of matrices from winery industry and also from other distinct foodstuffs. So Irene, the floor is yours.
Thank you very much. Good morning to everyone. First of all, I would like to thank the organization for giving me the opportunity to present our work about bioactive compounds from winery byproducts and innovative strategy in wine management. Well, doing a brief introduction, and as my colleague previously referred, Rui, the high production of wine implies a generation of large quantities of byproducts such as skins, seeds, stems, pomace, and wine lees. So it is very important valorization of these byproducts for an useful, efficient, and environmentally friendly processes. Among these residues, grape stems correspond to 25% of the total byproducts generated, and is the less characterized and valued of all the byproducts produced in the winery industry, representing up to 7% of the raw materials processed. Furthermore, usually they are discarded in open areas or used for composting, which can cause some environmental problems and consequently compromise the sustainability and competitiveness of this industry. Thus, it is important the adoption of new approaches, providing the application of these byproducts in the development of innovative and added value products in cosmetic, pharmaceutical, and food industries, since they are rich in bioactive compounds with beneficial properties for the human health, like antioxidant, anti-inflammatory, or anti-carcinogenic properties. According to the World Health Organization, the global growth of wounds incidents, especially those of chronic origin, is expected, which is why the demand for emerging products in the treatments of these wounds has been increasing. A wide range of approaches have been already applied in management of these wounds. However, the clinical effectiveness of these methods is still poor. In this sense, clinicians have increasingly recognized the value of the incorporation of bioactive agents into wound dressing materials as a novel approach to control, in this case, food ulcers infections. In this sense, the main goals of this work were to generate new knowledge on the potential ability of grape stems bioactive compounds in healing wounds. For that, some specific goals and preliminary works were already performed, namely the identification and quantification of polyphenols present in grape stems of muscatel variety at different regions during 2 crop seasons by spectrophotometric and chromatographic methods. Furthermore, the determination of antioxidant capacity and antimicrobial activity in vitro of the grape stem extracts against gastrointestinal and wounds pathogens. Concerning the sampling, the grape stems from muscatel variety were obtained from the Rhine region, Douro Valley, which in the north of Portugal, which is divided in 3 subregions, Baixo Corgo, Cima Corgo, and Douro Superior. The samples were collected from different wine farms, 2 of them located in the same subregion, and the third one
Sorry, I think we have no sound at the moment.
Yes, Irene, you are muted.
Don't know what happened. Sorry, I will show again my presentation. I'm so sorry. Are you seeing now?
Yes, all okay.
Okay, sorry for that. Well, once collected, the samples were analyzed concerning, after the grape stemming process, this plant was washed, freeze-dried, grounded, and submitted to a hydroethanolic extraction. Afterwards, the samples were analyzed concerning their phenolic composition, antioxidant capacity by 3 methods, and the antimicrobial activity was assessed by 2 different methodologies, namely the disc diffusion assay and minimum inhibitory concentration assay. For that, gram-positive and gram-negative bacteria were collected from human patients from the hospital center of Vila Real, and positive controls, namely commercial antibiotics, were also used as control. So, as results, the spectrophotometric analysis of hydroethanolic extracts of grape stems from the different regions during 2 study seasons revealed high content of total phenols, orthophenols, and flavonoids from the samples collected at Penajoia region, followed by Medrões and Sanfins do Douro. Furthermore, it's observed a significant increase of these contents from 2020 and 2021 for all these parameters. As expected, the antioxidant capacity of these grape stems also presented the same behavior than the content of phenolics, with Penajoia presenting the highest values. A significant increase of these values was also observed from 2020 and 2021 from Medrões and Sanfins do Douro samples, with the exception of Penajoia samples. Regarding the identification of the phenolic compounds by HPLC, an interesting content in hydroxycinnamic acid, stilbenes, flavonols, and flavones were found, with 8 compounds identified. Analyzing the amount of the individual compounds, we can verify overall that the higher content of phenolic compounds was found for Penajoia region again, with an increase of these compounds in 2021. Finally, regarding the antibacterial activity, the data obtained revealed that all tested extracts of grape stems revealed antibacterial activity for gram-positive bacteria. And concerning the capacity to inhibit the growth of gram-negative bacteria, the plates demonstrated that the samples of stem extracts were efficient only for Pseudomonas aeruginosa. So it is important also to note here that in some cases, stem extracts were more effective than the commercial antibiotics tested in this study. So with this work, we can conclude that the data obtained evidenced the great influence of the geographical origin and growing seasons regarding the final content in bioactive polyphenols and the antioxidant capacity of muscatel grape stems. The antibacterial properties of grape stems against bacterial wounds are promising results to further develop and apply a bio-based formulation rich in bioactive compounds in animal models to healing wounds. Thank you for your attention.
Thank you very much for your excellent presentation.
Thank you.
I'd like to open the floor for questions. I'd get kick started with the first questions, which is what is the next step for the development of these winery byproducts? What kind of studies are needed before this can be used as commercial healing agents?
Yes, as I referred in the title of my presentation, we are now developing a base formulation, a topical formulation, rich in bioactive compounds extracted from these winery byproducts, because as my colleague Rui said, the stems seems to be the best byproducts of the winery industries in terms of bioactive compounds. So now we are evaluating, preparing, developing the topical formulation rich in these extracts, and we are characterizing technologically this formulation, like the pH, the viscosity, and these parameters will be also performed up to 6 months, more or less, to analyze their stability.
Okay, excellent. I see that we have Ezequiel already ready to make a question.
Yes, thank you, Irene, about your presentation. It's excellent. And don't you think about incorporate this ingredients in other biomaterials, not only in topical formulations, but rigid biomaterials?
Yes, this is one of our goals. If this topical formulation will not be very a good material for the enrichment of these extracts, we will try also another polymers like ketosene, for example, which can help to develop this cream.
Okay, thank you.
You're welcome.
Excellent. We have another question here from Tiago Carvalho, which is, what are the main reasons why Penajoia has the highest concentrations of polyphenols?
Okay, as I show also in my presentation, Penajoia is a region of Douro region with the lowest between the 3 regions that we studied. Penajoia presented or are the region with the lowest altitude of almost between these regions. So the fact that is near the river can also help and or beneficiate the stems being rich in this compound. So here is the regions. There is a lot of factors that can influence these contents in bioactive compounds in all the plants, and the geographical region is one of these factors. And in this case, the lower altitude is one of the main reasons to these rich compounds found for the samples collected there.
Okay, excellent. Thank you very much. I don't know if there are any other questions. So if not, I'd like to thank Irene again. And
you're welcome.
I'll introduce now the last speaker of our panel, which is Ana Vilas-Boas. So Ana is a PhD student at the Catholic University of Portugal. And the main purpose of her research is to develop a sustainable approach to valorize orange peels to create a new dietary supplement to enhance the human gut modulation. She's a widely published author that had the pleasure of participating in the projects Essence and Fodiac, both of which aim to develop functional ingredients through the valorization of food waste. So, Anna, we're already seeing your presentation and the floor is yours.
Thank you, João. Good morning. My name is Ana Vilas Boas, and I'm going to present the results of the first part of my PhD work about bioactive compounds in orange juice byproducts. Orange is one of the most produced and consumed fruit worldwide. European Union countries contribute to it 6.2 million tons, which Portugal ranked the 4th place, representing 6% of the total production in Europe. In Portugal, sweet orange grow mainly in the south region and are a protected geographic indication fruit crop, representing a major economic impact for economy. There are two main uses for orange, the fresh consumption or the juice production. The last one represents about 25% of the total orange production in Portugal. And during this process, about 50% of the orange weight are wasted, being the peels the most representative byproduct. Due to their richness in bioactive compounds, it's possible to take an environment and economic advantage from the orange peel's valorization. Pectin showed several human health benefits, including the potential to reduce glucose and cholesterol absorption, and it's a good substrate for fermentation by gut microbiota. On the other hand, it has been reported that expyridine acts as a powerful antioxidant and anti-inflammatory compound. Moreover, expyridine showed in several human clinical trials antiviral activity against COVID-19 and also positive gut microbiota modulation. So, SWYP developed an integrative sustainable approach to recover all these bioactive compounds from orange peels. The application of step-by-step extraction is effective in separating the different compounds and achieving the zero waste concept. Attending to the fast market growing in functional foods, with the recovered bioactive compounds, we intend to create a value-added food supplement that induces the positive human gut modulation. However, before developing this circular economy approach to obtain the bioactive compounds from this byproduct, it's necessary to study the potential of Portuguese orange varieties. Therefore, for the first time was studied in terms of fiber composition and phenolic compounds, orange byproducts from the most representative Algarve citrus PGI cultivars, New Old, Valencia Leite, and Lan Leite. So we collect peels from 3 different lots of each variety from a supermarket squeezer machine. Still fresh but already crushed, we analyze the nutritional composition of the peels and the phenolic compounds. For the last one, we use a traditional method with methanol to assess the best yields, and after centrifugation step, 2 hydrolyses were performed in the pellet to assess the bound phenolic compounds. Overall, no significant difference are observed in terms of nutritional parameters. However, when we look at the results of fiber composition, we found that Lan Leite variety showed the least amount of soluble fiber and also the least amount of pectin. This can be explained by the fact of this variety has a very thin skin, and pectin is mainly found in the alveolate part. On the other hand, the New Old variety has higher amounts of pectin associated with the highest skin thickness. Regarding the phenolic compounds, the LC-MS analysis showed an extensive list of phenolic compounds. Here we have only some of them. Most of these compounds was identified for the first time in these varieties. Flavonoids are the major class of compounds in the free extract, and phenolic acids only are detected in bound extracts, because most of these compounds are linked to the cell wall, therefore needs a strong extraction, like a hydrolysis, to diffuse into the solvent. Furthermore, expyridine are only detected after acid hydrolysis. The release of expyridine could be related to the power of acid hydrolysis broken the linkage between the phenolic structure and the sugar moiety. The most representative compounds, as you can see in the figure, were quantified by HPLC. We can observe that expiridine is the most representative compound in orange peels, regardless the variety, accounting for 3.5 milligrams per gram of fresh weight in average. Narirotine and nobilitine are present in higher concentration in free form, mainly in new old variety, which may be associated with the fact of this variety grows during the winter and is subject to a bigger abiotic stress. Fulvic acid is the major phenolic acid present in bound form, mainly in lanolate and valencialate varieties. In conclusion, the lanolate variety showed less pectin due to its thinner peel. Expiridine is the most representative phenolic compound in orange peels, regardless the variety, followed by narirotine and nobilitine. All these compounds showed in vitro and in vivo bioactivities, including antioxidant, anti-inflammatory, and anti-proliferative activity in colon cancer. The phenolic acids are very difficult to extract from orange peels because they are bound to the cell wall fibers. And regarding expiridine, the most available form of expiridine, the release only happens in acid hydrolysis. The results showed that orange peels from Algarve citrus cultivar are an excellent source of bioactive compounds. Therefore, in future work is possible optimize the integrative and sustainable extraction to valorize in a circular economic context for application as a nutraceutical for health human benefits enhance. I would like to thank FCT for my individual PhD grant, to CBQF and MediSmart project for the funding support, and also to the Continent Supermarket and Frutas Trezo. Thank you for your attention. If you have questions, please let me know.
Thank you very much for your excellent presentation. So I will open the floor now for questions. I can start with a question of my own, which is thinking about converting your research into a commercial product. What would it be or could it be profitable for a juice producer, for example, to implement such an extraction method and to increase the bioactive ingredients of its products? How do you see it happening?
Yes, I believe that it's profitable, and there are some industries already extract some of these bioactive compounds. For example, the essential oils and the pectin. But nowadays, these companies don't have the extraction process optimized to extract all of these compounds. Normally, they extract one and stop there. And with our idea is take the profitable, the extraction of all bioactive compounds.
Excellent. Improving on circular economy and using up all of the byproducts.
Yes.
So I will give the floor to Marta to make a question.
You answer my question because I asked Hannah how your work contributes to a circular economy, so you answer. But you have any answer, different answer, you could say me, Hannah.
I don't understand.
How your work could contribute for a circular economy. So you extract your,
Okay, sorry. Yes, I think that my work contributes a lot for circular economy because we intend to achieve the zero waste concept. So our main goal is extract all the bioactive fraction from the orange peels. And in the end, with some of these compounds like expiridine and pectin and maybe cellulose, develop a food supplement for human health benefits enhanced. And this is a very strong circular economy approach, because we are develop new ingredients and new ingredients for human consumption, not for animal feed, for example. In human consumption, we have more economic impact.
Okay, thank you very much.
You're welcome.
Okay, thank you. Are there any other questions? If not, thank you very much. And I would like to thank to all the speakers of this panel. It was a very interesting set of works that we've heard about, and circular economy is looking very bright in what respects possible impacts for the health sector. So I pass the word back to my colleague Marta, who will introduce the next speaker.
Thank you, João, and all presenters for their informative and interesting presentations. Thank you to everyone who submitted the questions, to our excellent speakers for their presentations and answers. So, ladies and gentlemen, here we come to our second case study, Lidl, Portugal, with Mariana Diniz. I don't know if she is already.
I just received a message saying that Mariana is entering in some minutes.
Okay, we'll wait for her. Remember that you can tweet questions, so participate.
Yes, we are a few minutes ahead of schedule, so perhaps I would suggest a short 5 minutes break just before our next speaker, Mariana, will join us.
Yes.
And in the meantime, I make the appeal that we already have made in the chat box. If you want to introduce yourselves, talk about what is your research interest, and eventually what kind of collaborations you would like to find, use this opportunity, and yeah, make the most out of this conference. Thank you very much.
Mariana is joining in a few minutes, only 2 minutes she's with us. So.
You respect the time, so it's normal. For waiting for Mariana.
Yes, she was between meetings, so.
Thank you for all to respect the times.
Okay, we have Mariana with us. She just entered.
Hello?
Hi, Mariana. Hi, Mariana.
Hi, Christiana. Sorry, I wasn't hearing. I don't know if I'm hearing now. Can you please talk? Sorry.
Hello, are you listening?
Yes, I'm listening.
Okay,
Thank
perfect. I'll pass the word to Marta.
Yes, thank you, Mariana. I'm sorry because the time, we are entering the time, sorry. And thank you. It's my pleasure to introduce to our conference Dr. Mariana Diniz, who will present the case study of Lidl Portugal. So Dr. Diniz is graduated in communication science from the University of Lisbon and mastered in the same area in the field of communication, marketing and advertising from the Portuguese Catholic Universities. So now it works in Lidl Portugal since 2009 at CSR, a team where she currently performs functions related to the area of social responsibility, naming the management of projects related to foods, turma imbatível, certificação produto, social innovation, mais ajuda, and sustainability report, relatório de sustentabilidade. So let's welcome again Dr. Diniz, and the floor is yours.
Thank you. Sorry for the delay. I was on another meeting, and since it was 12:20, I thought I was okay. Good morning, everyone. I would like to start by thanking Smart Waste Young Professionals for the invitation to be here today at the second edition of the conference Circular Economy. Make it happen. Like it was said, my name is Mariana Diniz, and I'm part of the CSR and Sustainability team at Lidl Portugal. I'll be here today to talk a little bit about sustainability at Lidl and the entire value chain behind our business. At Lidl, we believe that what counts is the inside, and that big changes can only be possible if they start from the inside out. I will try now to share my screen. Please tell me if you can see it, please.
Yes.
Is okay? Can you see it? Yes.
Yes.
Okay, good. So this will be agenda for today. I will start by explaining Lidl CSR strategy, following the entire journey that our products make in the value chain, and finishing with our sustainability goals and initiatives. So, sustainability is a critical factor for Lidl's long-term presence on the market and for access to raw materials and food, which are essential for our customers. So the integration of sustainability in our DNA, and therefore along the entire value chain, comes from the need to reduce the environmental impact associated with the production of our products. So we are committed to protecting the planet, promoting sustainable lifestyles, and supporting local communities. Our mission is to offer the best to our customers, acting in a simple and sustainable way, and we aspire to have a responsible business that creates value for people and for the planet. The result is the creation of social and environmental and economic value for the stakeholders in our value chain and for the continuity of our business. It is within our value chain and thinking about the future of the environment and people that we seek to ensure a sustainable supply. So we start by ensuring resources and raw materials for sustainable sources, and then on the value chain, the next step is the supply chain. So is a chain of suppliers who are aware and committed to working in a more responsible way, with operations that guarantee a lower environmental and social impact. And finally, we have the education and awareness of our customers for responsible consumption, which is an important step also in the value chain. Next, I will explain here some of the topics that we address in each phase of the value chain. At the resources stage of the value chain, I'll address the topic of biodiversity and product certifications. Then at the stage of the supply chain, I will focus more on the circular economy topic, because it's the topic of the conference and it's very important for us and for our suppliers. Then on the operations phase, I will talk about the climate, the conservation of resources and the food waste. And finally, on our client phase, I will talk about sustainable products and corporate citizenship. So I will not start explaining which are our goals and initiatives. Starting by the phase of resources, from the beginning, this is the first stage, like I said before, and it talks about the acquisition of products with environmental certifications that reveals the contribution towards an agriculture that consumes more responsibly the natural resources. So there's we try to have more sustainable supply, and we are proud to say that we have over 600 own brand products from our permanent offer that have sustainability certifications. And this is very important because it's how we contribute to reducing the loss of biodiversity. It's by buying certified raw materials for our own brands with certifications such as MSC, ASC, FSC, Fair Trade, Global Gap, and Rainforest Alliance, and so much more that you can see here. So we started in 2011, by beginning of certificate our chocolate. Then in 2040, which started the certification of the cocoa in our cereals with the certification Fair Trade. Then in 2016, 100% of our fruit and vegetable suppliers were certificated Global Gap, and 100% of our cod was also certificated. In 2017, we increased the supply of MSC certified deep sea fish and seafood, and we abolished the sale of eggs from caged chicken. In 2018, for the first time, the entire Favorina, Easter and Christmas range began to use only UTZ and or Fair Trade certified cocoa, and we also increased the supply of ASC certified aquaculture, fish and seafood. In 2019, Lidl's cocoa products began to be 100% certified, so now we have 100% certified cocoa products with sustainable origin and 100% certification of our flower and plant suppliers originating in Portugal. Also, 100% of the raw materials of green, black and raw teas began to have also certification, Fair Trade, Rainforest Alliance, Organic or UTZ, and we also certified palm and palm kernel oil on our own brand food products. It's also 100% certified. We began also to have exclusive use of ground and organic eggs in our own brand products. So all the products in Lidl are made with ground and organic eggs. In 2020, Lidl's wood and paper-based food and non-food on-brand products began to be sources from recycled wood fiber or, when virgin, from FSC certified sources. In exceptional cases and due to limited availability of FSC raw material, PAFC certification can also be used. And finally, last year, we had more than 70% of our coffee certified, and 80% of the raw materials of herbal and fruit teas certified by Fair Trade, Rainforest Alliance, Organic, or UTZ. This is we are proud to say, like I said before, that we have over 600 own brand products on permanent offer in Lidl stores with sustainability certifications, and that we have overcome our goals to 2021 with more than 70% of certified coffee and 80% of herbal and fruit tier certified. Now, the second stage of the value chain, which refers to the production and processing of products by our suppliers, promoting a circular economy and with plastic strategy in which we have eliminated our plastic bags and are preventing now 675 tons of this material from entering the market per year. This is our plastic strategy, Reset Plastic, that we started in 2018, and that we committed, we design our goals for 2025. So we are committed to have 100% of our own brand packaging maximum recyclable, have also 20% less plastic in our own brand packaging and transport aids, and to incorporate recycled materials into our own brand plastic packaging whenever it's possible. We've divided our commitment into 5 action areas. So it's reduce, redesign, recycle, remove, and research. As such, Reset Plastic covers everything from avoidance through design, recycling and elimination, all the way up to innovation and education on the subject of plastic. We promote the circular economy through the redesign of our packaging. I will focus now on this action area, which includes the new responsible packaging stamp that says that packaging that has this step, preservamos recursos, embalagem ecorresponsável, contains at least 30% recycled material. The volume or weight has been reduced by at least 10%. It is at least 80% recyclable, and the packaging is made with more sustainable alternative materials compared to plastic. Concerning the remove action area, we are proud to say that we launched Transformar in 2018, and this project have collected more than 110 tons of plastic from Portuguese beaches in the recent years. Now, on the operations phase, this is the third stage of the value chain, and here I will talk about the operations at Lidl, namely on the environmental issues of conservation resources in operations, the fight against food waste, and the protection of the climate. In Lidl, we want to reduce our climate footprint in all operations, so we operate on 100% green electricity. The electricity that supplies our stores, warehouses and office comes from renewable sources. We are also building a national network of chargers for electric cars, and this is a commitment to electric mobility that contributes to the national goal of carbon neutrality. And finally, we are also increasing the number of photovoltaic panels in our buildings, such as stores, warehouse, and office. In order to save resources in our operations, we highlight the following initiatives. In our stores, we offer reusable and recyclable bags for fruits and vegetables, our green bags that can save up to 139 plastic bags per year. We also start started pilot projects for a refund and deposit system for beverage packaging with the aim of strengthening the national capacity to collect and forward beverage packaging for recycling. And we are now separating mixed plastics from our operations in order to increase the recycling rate and reduce the amount of waste sent to insemination. This separation also contributes to the selection of the best possible final destination for the various types of plastic produced, and it's a measure that is integrated into our plastics strategy. As food waste is a priority issue for Lidl, we defined also a strategy that focuses on 4 areas of intervention: prevention, donation, transformation, and awareness. So we prevent food waste through process that aim to improve the management of orders and stocks. Then we donate the waste that we cannot avoid to institutions that work to fight hunger. In transformation, we transform waste that we cannot avoid into animal feed, promoting a circular economy. And finally, we raise awareness for the importance of responsible consumption, for example, through projects aimed at the youngest, like our project Turma Imbatível, that raise awareness for the responsible consumption in schools. Finally, the last stage for our clients, quality and sustainable products will continue to be our focus. So by offering sustainable products in our permanent offer, we guarantee to our customers the possibility of having a healthy diet, and we are also committed to educate and help the local communities that we are inserted on, and that's what I'll be talking about in this last stage. So we, as explained before, we collaborate in partnership with certification organizations. Lidl has a 23% growth in sustainable supply in 2020 compared to previous years, with an increase in the number of the articles in all certifications such as ASC, MSC, UTZ, Rainforest Alliance, FSC, organic, and fair trade products. Lidl offers also 100% of sustainable palm oil, 100% of sustainable eggs, so it's eggs that come from ground, open air, and organic eggs. The sustainable herbal and fruit teas, it's also at 89%, 100% of sustainable green, black, and herbal teas, 79% of sustainable coffee, 100% of sustainable cocoa, and finally 36% of sustainable fish. And this is a work in progress. We are trying always to increase the number of certified products, because we think that it's important to offer a sustainable supply in which the environmental and social impacts are reduced. Finally, if we consider the total certified items, so including our permanent in-store offer and the promotional campaigns, we have 1,117 certified products in 2020. We offer an increasingly diverse range of sustainable products at affordable prices, and we try to have the most diverse offer possible. So we have like coffee, tea, chocolate cream, cookies, milk alternatives, and orange juice for breakfast, fish, eggs, and alternatives to meat, like our next level hamburgers for lunch or dinner. And we also have certified products to special occasions like the Easter and Christmas. In addition to offering products with sustainable sourcing. We try to educate our customers on the importance of supply products and sustainable consumption. And as an example, we talk about our certified products in our weekly flyers, as you can see on this image. To help the communities, Lidl implements citizenship initiatives that creates value for the Portuguese society. We have donated over 6.37 million euros in 2019 and 2020. In schools, we promote sustainability and healthy lifestyles through the project Turma Imbatível to children with ages between 5 and 10, which we think that it's important to begin to raise awareness from the youngest age. Lidl encouraged the acquisition of new skills in the third sector, so in social institutions, by promoting workshops on various management topics to try to give the best tools for these social institutions. And finally, we have also launched our good practice guide, Mais Ambiente, with tips to promote sustainable lifestyles and the 5 R's to circular economy that can be found in our website. So I was trying to be fast because I realized that you were waiting for me. To conclude my participation, I invite you all to visit our website and find more about our sustainability at our sustainability report. You can see the link here on the slide. And I would like to thank you all for listening and to congratulate the Smart Waste Young Professionals for organizing the conference about a topic that should be in the entire world agenda, which is the circular economy. Thank you. I can't see you. I'm trying to go back. I don't know if you have any questions.
Thank you, Mariana.
Thank you.
For your great presentation and interesting case study. So I have, people have questions for you. And first of all, Renato Guimarães answer, how does Lidl achieve the utilization of 100% renewable energy? Is all the energy produced by Lidl? I don't know if you
no, it's not all produced by Lidl. We also have external electricity. We have photovoltaic panels that give us energy, but it's not all the energy we use. We have like external sourcing.
Thank you. Benedita Chaves Aplipor said, congratulations for so many initiatives. Why did you choose to have paper bags instead of plastic bags? Do you consider them more sustainable? In what basis? Thank you.
Yes, we in 2020 we eliminated the plastic bags and we use not only paper bags that are recycled, but also I don't know how to say it in English, raffia bags. Those with are more efficient and more that holds more food, and the goal was to reduce our consumption of plastic and to also try that our customers bring their own and reuse, which is the goal. It's the best film yarn. Oh, thank you. So it's the best solution is the reuse of bags that can be film yarn or plastic bags or paper bags. It's our goal to reduce the consumption.
Thank you. Mariana, it's easy to be sustainable in Portugal. What are the challenges that you see? certification.
We in Lidl we have this particularity that we are an international company, so we work in sustainability. It's integrated in all of the international company. In Portugal, I don't see that as more problems to be sustainable than other countries. It's a step-by-step journey, and we have a lot of good practices from other countries, other places where Lidl try new initiatives and new projects that we can implement in Portugal. So we are always talking in group to reuse projects and initiatives and bring them to our country.
Thank you very much, Mariana, and it's a great example of making circular economy. It's open. Thank you. Now we will have a break to lunch.
Thank you.
After that, we'll continue with our ESTER sessions. So the following sessions will be a MIRIS case study with Brian Hedquist and more 2 sessions. Food bioeconomy moderated by Mr. Diogo Proença, and food bioresource, which will be moderated by Ms. Patricia Reis. For now, we will have a break and we will back to you by 2:30. Stay with us. Thank you very much.
Mas se quiserem tomar um café à hora de lanche, já era preferível. Está bem, Patrícia? Pode ser? Não, obrigada, até já. Aqui na reflexão, né? Tem que ver nenhuma coisa de mundo, ou é e depois fazemos essa combinado. Qualquer coisa de espera. Olha, eu tinha uma segunda-feira de relação, agora não sei se... Pois sim, não, LinkedIn, agora, não tinha tipo que eu alterei a noite falando lá, não, não sei. Olá, boa tarde. Pronto. Ok. Porque eu tirei agora porque eu não percebi agora que estava no título. Vamos ver. O link é o mesmo, é? O link é o mesmo.
Okay, hello. Can you hear me?
Yes, Ezequiel, we can hear you.
Okay. Perhaps we can start. Okay, we can start. Good afternoon, everyone. We are back with the online conference Circular Economy Make It Happen, second edition. My name is Ezequiel Coscueta. Like my colleague Marta, I'm a researcher at the Center of Biotechnology and Fine Chemistry at the Catholic University of Portugal, and I'm chair 2 of Smart Waste Young Professionals. I will be hosting the event during the afternoon. Before I continue, I remind you that this event is being streamed and will be available on the Smart Waste YouTube channel. Okay. I will now briefly introduce you to what Smart Waste Young Professional is. Okay. I share a short presentation now. Okay. Can you see the presentation?
Yes.
Okay. Okay. Smart Wage Young Professionals is a voluntary group open to anyone with 35 years or less that works or has interest on topics related to the circular economy. Smart Wage Young Professional born in 2020 with the vision of an economy without waste and the mission of creating work and knowledge sharing networks among young professionals who see waste as an important economic and social resource. We currently are 89 members distributed throughout continental Portugal, Insular Portugal, and Brazil. From the start, Smart Wage Professional has defined 5 key objectives, which include support young professionals with the development of this presentation. Okay. I lost in the presentation. Okay. Okay. The objectives which include supporting young professionals in the development of their career and fostering future leaders, and sharing knowledge, case studies, and good practices related to management of resources. This conference observes closely these 2 objectives. On the one hand, this conference aims to promote research performed by young professionals in Portugal in the field of circular economy. And on the other hand, it aims to support their careers, providing visibility and experience of presenting work in a conference held to the highest international standards. If you want to have more information about Smart Wage Young Professionals, or hopefully join the group, please visit the website shared in the chat box. Thank you. Okay, and now stop the sharing. Oops. Okay. And now we continue to our first speaker of the afternoon. I'm pleased to introduce you a remarkable invited speaker, Mr. Brian Edquist, VP Program Management and Circular Economy Ingredients at Amiris. Brian, the floor is yours.
Thank you. Good afternoon. And can I share my screen? So I'm pleased to share with you today a case study of a collaboration between Amiris and Católica University in Porto. This is a partnership that started about 5 years ago, and the company that I work for, Amiris, is focused on using synthetic biology, SynBio, to develop new ingredients that are more sustainable for consumer products. So we work with things like flavors and fragrances, like vanillin or patchouli. We work with cosmetics ingredients like squalane, and we work with food ingredients. We have a sweetener called Reb-M. And the idea was with this program was to move beyond synthetic biology into a circular economy approach as well, and to turn some of the waste streams that we have from fermentation into valuable products. This infographic looks a little, or illustrates what the Amiris production process looks like for our ingredients. It starts with the It starts with the harvest of sugarcane, which is used to extract sugar as a feedstock for the yeast. the yeast is specifically designed to produce the ingredient that's being targeted by the fermentation process, and that produces straw and bagasse and ashes as waste streams. From the fermentation process, there is another waste stream of yeast with liquid vinasse, and then finally, after the final purification or distillation of the final ingredient, there are other what we call bottoms in the evaporator that also have many different unique molecules in them. As I mentioned, this is a partnership between Amyris and Católica University in Porto. The idea here was Amyris had a strong interest in diversifying its portfolio beyond fermentation-based ingredients. We had the idea to find new applications for our biomolecules, and we were looking for a European platform to kind of expand in Europe from our base in North America. And Católica had those capabilities, really terrific team that we're collaborating with that has a lot of really relevant experience in the markets that we serve, and was really capable in helping us get the grant that funded this collaboration. We currently occupy the 3rd floor of the Biotechnology Center at UCP. The operations started in March 2019 and were fully functional by that summer. And it's really become a hub for biotech in Portugal. And the idea of the collaboration was to start with really understanding what are the valorization opportunities that we have from the various waste streams. That was where UCP really put in a lot of diligence and research, analyzing the composition of the waste streams, performing screens on bioactivity and other material properties of the molecules that looked interesting from those waste streams. And then Amyris has been ramping up its involvement, looking for the right partners to be able to commercialize and scale up some of these concepts. It's a $42 million project. The funding comes from ICEP and was total $25 million. The results of this collaboration is we created a new entity within Portugal. It's a profit-sharing entity so that Amyris Portugal and UCP both benefit from the business generated by these programs. There are about 70 people employed in Portugal by this collaboration, and we're hoping to publish around 15 publications and submit about 10 patents as part of this, as well as lead to new products for Amyris. This is another view of the research scope. And the waste stream I mentioned earlier on of the straw and bagasse, so PPS1 is what we call that. That is the first waste stream. The second waste stream is the liquid residues. Those are what I was talking about, the vinasse. We are exploring also spent yeast and the solid residues that come from that fermentation process. Those are the areas of product development. In order to enable those, we also created two other platforms within the grant structure. One was a software development platform to help us with the bioanalytics and the analytics around these programs. And the other was to look specifically at the fermentation process itself and look for optimizations there. As well as to develop the applied research testing in order to evaluate the potential for these ingredients to be a cosmetics ingredient, to be a food additive, to be used as a fertilizer or a animal feed and so forth. The team is our biggest asset. And I think one of the reasons this program has been successful is because of the cross-functional nature of this team. We've had researchers joining us from the food industry, from agriculture, from more of a pharmaceutical or health background. And we also have project managers, we have software developers, and chemists as well. It's been a really terrific team. About 60% of the researchers in Porto have PhDs, and many of them have industry experience as well as their academic experience. Here's a quick summary of the specialties that our team has. And I won't get into this in detail, but just it gives you a really good sense of the real diversity of this team and the capabilities it brought to the collaboration, and in order to consider the potential valorization opportunities from multiple dimensions. Here's a layout of our space. You can see also that the lab in particular has broad capabilities to do everything from the separation and analytics on the left-hand side here on the bottom of the waste streams to understand what the composition is, a fermentation lab that we can use to run new fermentations, and then also the ability to screen via various bioactive testing, microbiology assays, and we have a cell culture lab as well to do other in vitro cell culture assays. What's not shown here, and I think what's also very important, is that we have the capability to do small scale prototypes within this lab as well. Thinking about the platforms kind of on a more zoomed out view, this illustrates the capabilities that I walked through in the lab layout. Again, the abilities of us to do the separations, to analyze the structure and analytics, and then to make new molecules via fermentation and to screen them for their microbiome and bioactive activity. And on the right here, you can see a picture of one of our fermentation setups. So again, the idea here was to, from early in the project, consider what the opportunities are, analyze the feedstocks, analyze the bioactivity, analyze the value, the potential value from a scientific perspective, and then where we are today in the later stage of the projects is working through the product development and commercialization to understand what can be viably commercialized and marketed. And I think a really terrific case study, it's a work in progress right now, is our first prototype out of this collaboration. It's biosilica from sugarcane bagasse ashes. The idea here is that, you know, the sugarcane is grown in the field. We extract the juice for the fermentation process. That syrup is used as a feedstock for the yeast. The leftover sugarcane is burned to provide energy for the sugar mill. And those ashes are then converted into a biogenic silica product that can be used as a cosmetic ingredient. And we are currently trialing this and working on the process development and scale up for commercialization. We've also got two other ongoing projects. The first is a hand care product that arose during COVID. It was about a 500,000 euro project. It lasted 1 year, and it was to develop a squalane-based hand sanitizer that would be effective against SARS-CoV-2 and microbiome friendly. And the second is a vaccine grant around advancing glucans as a potential vaccine adjuvant. That was a 300,000 euro grant and also lasted 1 year. And again, I wanted to recognize that the team is really the biggest asset here. This is a photo of the terrific team we have in Porto. And I will close with a big thank you and to recognize our grant funders, ICEP Portugal 2020, and the European Union Development Fund, as well as our terrific partners at Universidade Católica and the team at Amyris.
Thank you very much, Brian. If anyone have any question, we have time now.
If you allow me, Ezequiel, I would like to it's not really a question because it's not really my field of expertise, so I cannot go into too deep in my questions, but it's more like a comment, because I saw that you are developing silica products from biosources, and I'm from construction sector. We also trying to explore new silica sources. So maybe we should sit down one day and talk a little bit and see if there is any possible bridge that we can make between what we are doing with Católica and or in the construction side. So thank you for your presentation. It was very interesting to me, and I just wanted to give this note. Thank you.
Thank you.
Brian, I want to ask, it's an opinion, if you see in Portugal the material to the human resources to improve to carry on with that kind of project like alchemy, if you think that in the future will be more projects like this.
Yes, I certainly think so. The alchemy team has been terrific, and Amyris is hoping to renew, or I shouldn't say renew, request another grant and continue the collaboration for a next generation of this project. That's very early stages. But I think generally in Portugal, you certainly have the human resources to continue these kinds of collaborations with other industrial, to continue either on an industrial academic partnership basis or to pursue a circular economy, within businesses.
Thank you. Thank you.
Can I do a follow-up question on that? Because indeed, I think that I can easily recognize that we have a lot of scientific human resources at master's, PhD levels. But what about other facilitators or barriers? Are you finding anything about Portugal that can make this kind of projects work, or any barriers preventing it? How do you see the future in that sense?
I think with circular economy generally, that it's not, I would say the biggest barriers are not to Portugal specifically. They're more related to the existing kind of linear economy and the economic incentives and the technical structure that's in place today. For example, it's very challenging to valorize a waste stream when it's considered by garbage by other companies, and they don't take care of it to maintain the quality of that, which if you had economic incentives in place or policy in place, those feedstocks could be of a higher quality, which could enable upcycling or continual reuse to a much higher degree at a much more ecologically sustainable way. And plastics recycling is not a field that we're interested in, but I think is a great case study in this, where there are a lot of recyclable plastics, but the infrastructure to recycle them and the economic incentives to encourage consumers of those products to recycle them, and also to encourage businesses to use those recyclable plastics are not as strong as they could be.
Thank you.
But I don't think that's unique to Portugal. I think that's, or to the United States or to anywhere. I think that's a general kind of broad challenge.
Okay. Thank you very much, Brian, for your excellent presentation. Very valuable for us, because we want from Smart Waste Young Professional, we want to thank very much you. Thank you.
Thank you. I'll let you guys continue with your seminar. Have a wonderful day.
You too, you too. Okay, we now move on to our third panel. For this, I'm pleased to introduce the moderator of this panel, Diogo Neves Proença. Diogo is a junior researcher at University of Coimbra. He is involved in several scientific and communication projects and has been served microbiological societies in many roles. He has an undergraduate degree in biochemistry and completed a PhD in biochemistry with a specialty in microbiology. Diogo, the floor is yours.
Good afternoon. Thank you very much, Isquel, for this kind introduction. I'm very happy and pleased to be sharing this session. All the presentations, as you know, have 7 minutes, and if necessary, I will just interrupt at the end of these 7 minutes in order to not create delays in the program. After the presentations, we have, after each one, we have 3 minutes of discussion and questions, and the questions will be raised directly and not in chat. So let's start. We start with our first speaker, Eunice Costa. She is a research fellow at Universidade Católica Portuguesa. She has a bachelor in biotechnology and master's in molecular biology, biotechnology, and biointernship in plants. Today, she will talk about microbiomes and brewers. Please be welcome.
Everyone can hear me? Does everyone can see my presentation?
Yes.
Oh, great. Okay. Hi everyone. My name is Eunice. I'm here to present our work about how does the knowledge on microbiome can help advancing the valorization of pre-spent grain through volatile fatty acid productions. Biotechnology process using mixed cultures depend on the complex cooperation between microorganisms inhabiting the system. By linking the microbiome structure with the operating parameters and performance of biological process, more efficient process for converting waste into added value compounds can be obtained. In our case, pre-spent grain is a lignocellulosic byproduct generated by brewing industry, and it is available in large quantities. It's a byproduct concerning 85% of waste of the dairy industry, and there are several studies regarding its application. Normally, it is used for animal feed, but we are studying an alternative valorization process on volatile fatty acids production through anaerobic digestion. So we operated a bioreactor containing anaerobic granules, and we fed continuously with pre-spent grain. pH fluctuations were applied to the system, and we analyzed the content of VFA in the mixture and at the same time, the microbiota within the granules to link the VFA contact to the microorganisms. On stage 1 of operation, pH was set to 4.5 and acetate and butyrate were the main VFA on the mixture. During this period, bacteria Prevotella, Osanella, and Caproicidocen, sorry, it's a very complicated name to pronounce, were the most abundant genera in the microbiome. On stage 2, when pH was changed to 3.9, as you can see in the graph, the microbiome shifted and lactobacillus dominate the microbiome composition, and lactate became the most VFA dominant in the mixture. When we reset the pH to 4.5, the VFA profile and the microbiome composition were similar to the obtained on stage 1. So, for concluding, a deeper understanding of microbiome dynamics improves the ability to manipulate it for a desired VFA mixture production. Downstream applications of the VFA mixture produces depends on the type of VFA present, and ending up, the outcome can help advancing bioconversion process for waste valorization. Thank you for your attention. If you have any question, please just ask me.
Thank you very much, Eunice. Any question from audience? Okay, I think we have plenty of time, so I can start with one question. And let's see if someone raised any question. Do you know if these bacteria that you mentioned are involved in production of these fatty acids or are involved in its consumption?
Production. In this production, the specific bacteria are related in several articles by being producers of these volatile fatty acids. Yes.
And did you isolate any of these bacteria, or just looking for microbiome?
No, we just evaluate the shift of the microbiome through pH, so we can link it to the VFA that we obtained. In these 5, actually these 3 that I've mentioned, but as you can see, I presented 5 of them. These 5 were the most top genera that we found on the microbiome. They were the most abundant on it.
Okay. There is also Caterina Miranda. You can talk.
Hi.
Yes, I can
Thank
hear
you very much for your presentation, Miss. I have one question. Could you please explain some of the applications of these volatile fatty acids?
Yes, of course. These volatile fatty acids can be used on the production of bioplastics, a two-step production. They can be used also as a consumption of they can be used as a carbon source for microorganisms. They can be used in the production of biofuels, biochemicals, food suppliers, etc., etc., etc. There are several applications. Some of these applications are already being studied, but yeah.
Okay, thank you.
Hi, everyone. Can I ask a question also?
Let's go ahead then.
Hi, Nis. Thank you for your presentation. How do you explain the presence of lactobacillus?
The presence of lactobacillus, it's explained because we shift the pH to 3.9, which is a drastic shift, and lactobacillus generally enjoys acidic pH. Also, which is good, we have this drastic change in the microbiota because it means that the profile of the volatile fatty acids that we found also shift, which indicates that these compounds are depending on the type of microbiota that we have on the reactor. Did I answer your question?
Yes, thank you so much.
Hello, everyone. Thank you, Eunice, for your presentation. I would like to ask you if your profile has only those organic acids that you mentioned. Thank you.
No, not just acetate, not just butyrate, not just lactate. We had actually evaluate a lot of more organic acids, but these 3 were the most abundant in the VFA profile. And so to present you the main abundant, I rather to show only the shifting of these 3. But we also had production of, for example, valeric acid, propanoate acid, and isobutyrate and isovalorate also. But this remaining VFA were present, but in low quantities.
Thank you.
Thank you. Any question? Yeah. And this theme is also special for me because we are producing bioplastics with bacteria, and we are now starting to use lactic fatty acids. So, and thank you very much, Eunice, for your presentation.
Thank you.
And good luck for your work. So now we can move for the second speaker, to be Ana Rita Mateus. She holds an undergraduate degree in bioanalytical sciences and master in food safety. Currently, she is PhD student at pharmaceutical sciences at the University of Coimbra. And today she will talk about pistache shells and mycotoxins. Please be welcome.
Hello, everyone. Can you see my screen? Yeah? Okay. So my name is Ana Rita. I'm a PhD student, and today I will be presenting part of my master thesis regarding the valorization of pistachio shells with a different perspective. So why pistachios? Oh, okay. Why pistachio? Pistachio is one of the most consumed tree nuts in the world due to this special flavor and nutritional quality. They are low in calories and high in monounsaturated fatty acids, which is related with health benefits, especially in cardiovascular system. So in 2020, more than 1 million tons of pistachios were produced worldwide. However, only 50% of pistachio is edible, and consequently, a huge amount of shell is wasted every year. So, several studies indicate that these shells are rich in bioactive compounds such as gallic acids, tannins, and camphorol with antifungal properties, since the shell is responsible for the protection from fungal contamination. In the other end, pistachio is one of the tree nuts with a higher risk of mycotoxins contamination due to the early shell split at the end of maturation. So pistachio is susceptible from fungal contamination and, as consequence, mycotoxins. Mycotoxins are secondary metabolites of fungus with adverse health effects in humans. And in pistachios, aflatoxins are the most reported ones, especially aflatoxin B1, which is classified as proven carcinogenic for humans. In recent years, ochratoxin A and some emerging mycotoxins have also been reported in some studies. So in order to have it's important to ensure the food safety of those byproducts to have a safe circular economy. With this aim, this study developed an analytical method for determination of mycotoxins in pistachio shells. So the method should be sensitive enough because mycotoxins are present at low concentrations, and the extraction and the cleanup are the crucial steps for these methods. So this method apply the quick, easy, cheap, effective, route, and safe, the Quechers method, which is a simple method to do the extraction of mycotoxins using quite normal equipment in a laboratory with less use of solvents and reagents. In this case, we use acetonitrile as extraction solvent, followed by a cleanup step using ZSEP, which is modified silica gel with zirconium oxide to remove any interference from the matrix. The final vials follow for injection into ultra-high performance liquid chromatography, combined with time-of-flight mass spectrometry for detection and quantification of mycotoxins. The liquid chromatography is the golden standard for mycotoxin determination, since they have a high sensitivity and low detection limits. And mass spectrometry is useful to identify molecules based on molecular weight with a high mass accuracy. This technique allows the determination of multi-mycotoxins, which is important because one pistachio shell could be contaminated with one fungus that produce more than one mycotoxins or have several fungus, resulting on the co-occurrence of mycotoxins. So the final method was validated for determination of 8 mycotoxins, the 4 main aflatoxins, ochratoxin A, zerlonona, toxins T2 and HT2. The validation of this method show a good recovery, repeatability, and precision interday, all in accordance with the criteria established by regulation for mycotoxins analysis. Also, the limits of detection were lower than the maximum levels they are established for mycotoxins. So this method allows the determination of mycotoxins according with current legislation for mycotoxins. So with this validated method, we have studied 11 pistachio shell samples that were acquired in different supermarkets from Portugal, and we have selected different types of pistachios, the raw, the roasted, the salt, from biologic agriculture and different origins. And after the application of this method to our pistachio shells, the results show that aflatoxin B2 was the only mycotoxin that was detected by the method, but all at low concentration, lower than the maximum levels they are established. So in conclusion, the analyzed pistachio shells were considered safe regarding mycotoxins contamination and also the limits they are established for edible pistachios. So these shells have a possible safe application for circular economy approach, for example, using active extracts for active food packaging with antimicrobial activity, or as food ingredients or food additives, since in recent years, due to the toxicological and carcinogenic effects regarding synthetic additives, there is a trend to search for more natural food additives. So pistachios could be one of that options. So thank you for your attention. If you have interested in this work, we have that QR code that goes directly to the article that it's published in Molecular Journal. And if you have any questions, now it's the time to answer them.
Thank you very much, Enrique.
Thank you.
I would like to ask the audience if anyone has questions.
Yes, I have a question. Ana Rita, have you already trying an application, a prototype to apply this ingredient, because perhaps it's a good alternative to myelin packaging, for example?
Yes, right now I'm not working with these pistachio shells because it was the metrics for my master thesis. I'm searching for fundings to continue my work, and the application for circular economy is the future to work that I have to do. I'm sorry that I have no answer to you.
Yeah, thank you.
And there's also just following before I go to Andrea. What are your next steps since you have the maximum levels of mycotoxins?
Because the pistachio shells that we use are safe for the future use. And right now, my PhD work is working with fruit byproducts with the same proposal. So I have to attempt to use these pistachio shells for further applications too.
Okay, thank you. Andrea, please.
Thank you, Anna, for your presentation. My question is, did you have tested any other extraction technology using ultrasound-assisted extraction or microwave, or you have only used the acetonitrile extraction?
Yes, I use just the acetonitrile extraction, the solid phase extraction, and the optimized method was changing the sorbent of the cleanup step to have a better analysis and a good validation of the method. But yes, it's one of the work that I'm currently doing is apply more green extraction techniques for these extracts.
I think it will be better for a circular economy approach.
Since we want to use food grade solvents for future uses too.
Of course. Thank you, and well done. Bye-bye.
Thank you very much.
We still have time for any one or two questions.
Yeah. It's not a question, but I can do a comments about my work because they are a little bit different of the aim of the other works working with other byproducts. Since I'm searching for the food safety, and I think there is a lack of studies regarding the safety of those byproducts, because the huge advantage of those byproducts, they are rich in active compounds, antioxidants capacity, and antimicrobial agents. Are several studies talking about that, but there is a lack of research on safety, and this is compromising all the circular economy.
Yeah, it's true. Okay, since we don't have more questions, thank you very much, and good luck for your PhD.
Thank you very much.
So let's move on to Mariana Pedrosa. Okay, yeah, she is. She holds a bachelor in material engineering and master degree in chemical engineering. Currently, she is a PhD student of biotechnology at Universidade Católica Portuguesa in partnership with the Centro de Investigação de Montanha. Today, she will talk about olive byproducts. So please be welcome.
Thank you for the introduction. Everyone is seeing my presentation?
Yes.
So, good afternoon, everyone. My name is Mariana Pedrosa. Actually, I'm work at Centro de Investigação de Montanha, and today I'm going to present my work about olive byproducts approaching the bioactivity of leaves for food application. I will begin with a brief introduction, and before they start, I just would like to tell this is a second stage of a broader research about olive leaves. So the olive tree, it's a plant, it's a tree with cultivated in more than 40 countries with great relevance in the Mediterranean countries. And the European Union is responsible for more than 70% of the olive oils productions, and the olive and the olive oils are the main product from this tree. It's important to say that the olive oils move around 7 billion euros per year and in the European Union. And during the process and the harvesting and the tree pruning, it's generated a lot of sub-products like the leaves, branches, and waste. So in this work, we focus on the leaves to study the potential use of these byproducts. So the leaves can represent more than 10% of mass harvests. So can be major burdens for the industry as well as for the environment. So find new innovative ways to add value and incorporate again these leaves in new processing chains is important to contribute to the circular economy for a more sustainable process. So the leaves are low-cost alternative for bioactive ingredients for the food industry. The leaves are rich source of phenolic compounds, which are bioactive compounds. And in addition, with the new consumer demands for more natural foods, more healthier foods, this work aims to study the bioactivities, some bioactivities of the extract of the leaves, to study the potential as natural preservatives in foods. The materials and methods applied was first, we prepare the samples, drying the leaves and grinding them. Then we perform two extractions with two different methodologies, with the ultrasound assisted extraction and with maceration, with optimal points performed previously in the research. Then we perform the antioxidant activity with two techniques, the cellular antioxidant activity and with the bars, the thiobarbituric acid reactive substance with the both extracts, and then antimicrobial activity and measuring the antifungal and the antibacterial bacteria. So for the results and discussions, first about the antioxidant activity, the first result was with the CAA, the cellular antioxidant, for both extracts. Both extracts showed similar results, and the result was in function of the percentage of inhibition at the maximal concentration tested, which was 200 microgram per milliliters, and the bars was measured in function of the EC15, which is the concentration of the extract, able to provide 15% of the antioxidant activity. In both analyses, the maceration extract showed higher values than the ultrasound extract. And going on with the analysis, the antimicrobial activity was measured with the minimal inhibitory concentrations related to the bacterial growth. And for the bacteria, only in two bacteria, the Morganella and Proteus, the extract showed better results than the control, the ampicillin. And once more, the maceration extract had higher results than the extract obtained by the ultrasound. And going on with the antimicrobial activity related to the fungi activity, both extracts had similar capacity, as we can see in the graphs, and both extracts showed low antifungal activity compared to the controls. And so, to conclude, in general, the maceration extract showed better results and then ultrasound, either in the antioxidant and on the antimicrobial activity. And the olive leaves extract showed stronger antioxidant than antimicrobial properties. And for future steps, we aim to incorporate those extracts into foods to study the shelf life and evaluate the preservative effects to see the potential use in foods in the food industry as a substitute for these synthetic additives. So I would like to thank my supervisors, SIMU and FCT for my scholarship and everyone for watching. Thank you.
Thank you very much, Mariana. Any question from the audience?
Yes, Diego, I have a question for Mariana. Yes. Hello, Mariana. Thank you for your presentation. It was very interesting. I would like to ask you why you focused on the leaves and exclusively on the leaves, and why not to test other sub-products from olive oil industry, like the peels and the core of the olive. So this will not be something that is worth to see, or is something that you are planning to do in future works?
No, we focus on the leaves because it's a byproduct with huge amount of quantity generated, and at SIMU we study a lot of like the leaves, this part of the plants. So we think this first approach, it's good to see on the leaves these bioactivities on the leaves.
Thank you.
I answered your question, or
yes, I understood that you start by looking at the leaves.
Yes,
but maybe look at the other byproducts. Maybe there is some potential there as well.
Yes, I think in this first step, we're just seeing at the leaves, and maybe in the future we could see other parts of this of the tree or process. Thank you. Thank you for the question.
Thank you.
We still have time for 1 or 2 questions. I can raise one. Why did you choose that bacterial strains to test the antimicrobial resistance?
It's because our bacteria from the food bacteria most common, like when we test we have another kind of we had the food bacteria and we had another clinical bacteria, and we choose that one because was more related with the food industry.
You mean bacterial pathogens?
Yes, yes.
Okay. Anyone? Okay, thank you very much. We can move to our last speaker in the session. So will be Ana Sofia Souza. Okay, she's already turned on the camera. And she holds a master in pharmaceutical sciences. Currently, she is a PhD student at the Universidade Católica Portuguesa and the I3S Batimub in PhD program. And today she will talk about antioxidant, antimicrobial properties from bioresidues. Please be welcome.
Thank you for the introduction. Are you watching my presentation?
Yes, perfect.
Okay, perfect. So, good afternoon. My name is Sofia, and first I would like to thank the opportunity to present my work, which was developed in the context of microbial extract project and focus on antioxidant and antimicrobial properties of aqueous extracts from Pleurotus eringi bioresidues. It's not working. Okay. Mushrooms, in particular edible mushrooms, are considered the next generation food as they are important natural source of nutrients and bioactive compounds with health promoting benefits such as antioxidants or immunomodulatory activities. Polysaccharides, proteins, and phenols are examples of bioactive compounds present in mushrooms. So, the mushroom's global production and consumption are increasing. The production of fresh mushrooms results in many waste and non-conforming products, and which may account for then more 20% of a crop volume and contributes to a production costs and a negative environmental impact if not used. These products consist mainly of stalks, mushrooms, or irregular dimensions and base material. So, the valorization of mushrooms bioproducts provides an opportunity to develop high-value products. The bioactive compounds obtained could be applied in developing food and nutritional formulation and other applications such as animal feed, fertilizer, energy production, and cosmetics. The main purpose of this work was to evaluate the potential of aqueous extracts from Pleurotus eringi bioproducts to exhibit antioxidants and antimicrobial activities and be a good source of phenolic compounds and beta-glucans under a circular bioeconomy approach. The extraction was performed using water as the only solvent to obtain a process as green as possible and with minimal costs. In addition, can't be easily scaled up at the industrial level. The aqueous extracts were obtained using 2 different methods. In method 1, the simple one, a hot extraction was performed, obtaining extract 1A. On the other hand, in method 2, a room temperature extraction was first performed, resulting in aqueous extracts 2A. And then the resulting residue was extracted with water, and the resulting extracts to be. All the extracts were freeze-dried, and then the bioactivity of the extracts was assessed, measuring the antioxidant power and antimicrobial properties, especially against foodborne pathogenic bacteria. Moreover, the contact of total phenolic compounds and beta-glucans was also evaluated. Regarding extraction yield, the results indicated that method 2 overall was the one with the highest yield. However, no significant difference were observed among the extracts 1A and 2A. Besides, phenolic compounds were found in all extracts. Regarding the antioxidant activity, the results showed that the extracts are a possible source of natural antioxidants. In general, the antioxidant activity of extract 2B was higher than others, which allows for predicting a potential biological antioxidant of these extracts. Beta-glucans are the major glucan constituent present in mushrooms and represent 13% of the total dietary fiber. Concerning the extracts, extract 1A has higher beta-glucan content, which allows for predicting a potential natural source of these compounds with immunomodulatory activity. The extracts does not show xenotoxic effects, but only extract 2B did not show cytotoxicity. In general, the extracts of Pleurotes syringae inhibit bacterial growth. The extract with the best results was 1A for all bacteria tested, so it could be interesting to explore its application to develop food conservatives or food coatings. None of the extracts tested was bactericidal. So, according to the results, these extracts of Pleurotes syringae bioresidues can be a good natural source of phenolic compounds, beta-glucans, and compounds with antioxidant and antimicrobial activities. Thus, the valorization of these mushrooms waste is available for development of green value-added products with great potential for application in nutraceutical or food products, contributing to a circular economy. In this sense, these bioactive compounds could be a new alternative source of antioxidant, as I showed earlier, extracts from method 2 are good for this, and antimicrobials, especially using extract 1A, as natural food conservatives or food coatings that guarantee food safety for extended periods without compromising the sensory and nutritional aspects. Also, it will be interesting to evaluate the prebiotic potential and the phenolic compounds profile of these extracts. I would like to thank all people and institutions involved in this work, especially in the microbioextract project, and thank you for your attention and for your time.
Thank you very much, Fia. I'd like to ask the audience for questions. Elena, please. There's one question in chat, so you can talk if possible. Okay. Probably Elena cannot speak, so the question is, in your project, did you already prepare coatings with your extracts?
Thank you for the interesting question, Elena. Yes, we already have some work in this area on developing or production of coatings from extracts, and namely extract 2B. It's a promising one with bioproducts from other species of mushrooms, such as Pleurotes or striatus, and there the next step is to test the coating on food products.
Okay, thank you. So, Andrea, please.
Sorry.
Thank you, Anna, for your candid presentation. My question is, did you try again? I'm going to talk again about the extraction technology. Did you try any other extraction technology, or did you use only the water at 90 degrees of the temperature, if I understand? And you didn't use the water, pressurized water?
Thank you, Andrea, for your question. At CBKF, we only use water as the only solvent because we want to make a simple, green and lower cost process, but other partner institution of the project develop hydroethanolic extraction using ethanol. And in fact, this type of extraction are the ones that we are most found in literature to obtaining bioactive compounds from bioproducts, yes. But we only use water.
You can find better results using water under pressurized. You can pressurize water in the batch reactor, and we can find better results with this type of extraction technology, because you can put the water also under without oxygen and nitrogen conditions, so we can have better results with this technology. You can find some results about our group. If you find, I can send you my email if you want, and you can find some results. And we found better results with this technology.
Okay? Oh, that's great! Thank you for sharing your knowledge and your work. Thank you very much.
I will send you my
yes,
my
please.
Email, okay?
Thank you.
Thank you.
That is great. So, any question? I have one. So, do you know any action mechanism of these compounds in antimicrobial effects? Are these compounds specific only for bacteria or also to fungi?
Well, we don't study yet the mechanism. We think about some bioactive compounds that mushrooms have in their constitution, like phenolic compounds, and maybe some polysaccharides may have this ability to inhibit bacteria, but we don't study yet the profile of the possible compounds that have this action.
Okay, thank you.
Thank you so much.
One question more, anyone? Okay, so I can conclude the session. Thank you all the speakers for your time and your work. That is very appreciated. And now it was also my honor to be chair of this session, and I pass the word to Ezequiel. Thank you.
Thank you, Diogo, and thank you all the speakers. It was a nice session, and now we are anticipating to the hour, so we now moving to a break till 4:15, so you can go for a coffee and so on. So see you soon at 4:15.
Não tenho aqui. Pô, mas não está aqui. Mas quando nós chegamos, eu tenho uma live. Supostamente,
Hello. We are back for our fourth panel. For this, I'm pleased to introduce the moderator of this panel, Patricia Reis. Patricia is a responsible business analyst and a digital content creator at her project Reutilizar a Mente, in which show us that almost everything can be upcycled or reused. Patricia has an academic background in the field of environmental engineering and in biochemistry. So Patricia, the floor is yours.
So thank you so much, Ezekiel. Can you hear me? Is everyone hearing me? Yes, thank you. Thank you for introducing me to the conference. I'm really glad to be here. Since I'm surrounded by some amazing researchers and projects that promote circular economy, so that's really awesome and really good to watch and to listen to those researchers. So I'm going to present the fourth session of today, which is about sustainable resources. For our first presenter, I'd like to introduce Guilherme Ascensão, whose presentation title is Development of Functional Mortars with Improved Hygroscopic Properties. And Guilherme is a PhD in Material Engineering by Catholic University of Leuven, and PhD in Civil and Environmental Engineering by the University of Padova. And he is integrated researcher at RISCO, Research Center for Risks and Sustainability in Construction from Civil Engineering Department in University of Aveiro, and a researcher at Secolab, and he works concerns the valorization of industrial wastes and byproducts. So Guilherme, the floor is yours.
Thank you, Patricia. Thank you for your kind introduction. And it's good to be back, this time in the quality of presenter and not moderator. And believe me, it's much easier for me to be in this role. So I will just try to share my screen so you can see my presentation. Okay, so as Patricia told, the title of my presentation is Development of Functional Mortars with Improved Hygroscopic Properties, but you can see that I put under hygroscopic under brackets because this is, I will present part of the work that was destined to improve several properties of the mortars. I will talk a little bit during the presentation, but today I will focus more on the hygroscopic properties than any other. Allow me just a minute to present ourselves, who we are and what we do. We are a small research unit with 23 members that focus on three main topics: risk assessment and mitigation measures, building heritage conservation and renovation, and sustainability and resource efficiency in construction. Our main mission is to contribute to sustainable and resilient cities. Then this general objective can be divided and multiplied in several more specific topics. And I'm particularly involved in these three: smart and eco-efficient construction materials, well-being of building inhabitants, energy, and water efficiency. As a group, we have simple questions to address, but with complex answers. So what, when, and how should we build? What resources should we use? What do we get in return as a society, as owners, as stakeholders? And what happens next to the materials, to the building elements? Can we reuse them, recycle them? To which extent? What are the environmental impacts of these actions? So these are the questions that we try to address. So we believe as a group that part of this, the answer for these questions and for having a good response for these answers, we need to build more sustainable, more circular, and more smart built environments to cope with the rest of the transformations that we are seeing in our planet and in our societies. So we are addressing this in several fronts. I just put here an example, 2 or 3 examples. So we have increased the amount of sensoring in our buildings, in our building materials, from toilets to other parts of prefabricated modules. So we have more response building elements and construction that can respond to different stimulus. And also to use industrial wastes as alternative feedstock materials for construction projects. My colleague Fabio will talk a little bit more about this in the following presentation. Also to add functional properties to traditional construction materials. Also to investigate new building technologies. Here is radiant floor systems, and also to use novel manufacturing processes to deliver complex geometries with improved functionality and reduce the amount of materials that we use. So the work that I will briefly present today is about mortars and rendering mortars that cover a significant part of our building environments, indoor environments. And we look at mortars in this work as a white canvas that we can functionalize with different additives to deliver different properties. So in this work, we try to improve three qualities of mortars: its storage capacity, photocatalytic ability to reduce airborne indoor pollutants, and also improving moisture buffering capacity to control relative humidity levels in indoor environments. So I will not talk much about the two first parts of this work, but in the nutshell, we did some chromatographic analysis. We also built some test samples and simulate different environments. Also in photocatalytic activity, we test different concentrations of pollutants and simulate both indoor and outdoor environments to see how these pollutants could be degraded. When it comes to moisture buffering capacity, we test different additives, polymeric additives, mineral additives, and organic additives. We start with sodium polyacrylate, which is a well-known material or additive to absorb and release water. You can find it, for instance, inside diapers in commercial stores. But this material has some problems associated to the environmental impacts of its production. Also is very costly for the construction sector and impose some deleterious effects on the technical properties of mortars. So we try to replace at least part of this sodium polyacrylate for mineral additives like vermiculite that has this shape of an accordion and can retain water and release water in this structure. But we want to improve this and be as circular as we could. So we tried also spent cellulose fibers from paper industry and cork granulators from the cork industry that are not used in cork products. So is a residue from cork industry. So of course, when we add these additives to construction materials, we need to cope with standard regulations and measure a bunch of properties that should be in accordance with the current standards. So from fresh properties like spread, setting times, rheological properties, and also iron state properties like density, mechanical and physical properties like carbonation and so forth, so on. And these last circular samples that we see on the right side of your screen, we did it for test the moisture buffering capacity. So the capacity, the ability of the mortars eat and release water.
1 minute left.
Okay, so this was just to illustrate the decay of properties when using SAP. So to further justify the need for reducing the use of SAP. And here you can see this curve, you can see the positive effect on the ability of mortars to retain and release water when using SAP, but you can also see that there are some hysteresis effects. So the material loses capacity over cycles. So we need to improve this. And so for us, the logical step next was to bundle different additives and try to see if synergetic effects we could overcome these issues. And in fact, we could double the moisture buffering capacity values for 1.27 to about 2.3 when combining cellulose fibers and one small percentage of sodium polyacrylate, and still keep some acceptable mechanical properties with the mortars. Not great, but still acceptable under current standards. The effect that we could see was that mixing these two additives stabilized the performance of the mortar over cycles. We can see the curves of absorption and desorption getting constant over time. So this is also important when it comes to construction material that have a lifespan of 10, 20, 30 years. This is a very important feature. So the next step for us was to do multifunctional mortars, try to combine phase change material, sodium, titanium dioxide, and sodium polyacrylate and cellulose fibers. Of course, today I don't have time to show you this, but we are working on this project. So if we next time we will show the results, and in the meantime, if you have interest, let's collaborate, let's talk about it, let's stay in touch. So this was the final message that I want to give here. And of course, a final word of acknowledgement to FCT that has sponsored my work for the last years. And I could not finish this presentation without acknowledge to FCT. Thank you, and thank you for attention, and sorry for exceeding a little bit my time.
Thank you so much, Guilherme, for your excellent presentation. I don't know if someone in the audience wants to ask a question.
Yes, I have a question. Guilherme, do you have think about use this kind of material, for example, to fix some kind of bacteria to bioremediation? Because some microorganisms can act to bioremediation, for example, to fix or to transform some polluants. And if you can use it in construction of some buildings or the next construction, that at the same time of have support for a building to have at the same time it acts like a bioremediator.
Sure. Of course, that first of all, most construction materials like cement and mortars have already some capacity to resist to pollutants, mainly due because they have low porosity and because of the high pH, the alkaline environment per se already has some of this effect. Of course, we can improve it in these microbiotic or antiseptical properties. We did some preliminary tests. I have to admit that the results weren't great. So it's something that we are looking at. We still have some work to do in this area, but definitely COVID sparkled this thematic in our group, and we will do further tests, of course. I cannot guarantee that we can improve this feature to the point that is feasible to the market. And this, for instance, titanium dioxide is very interesting and presents some very nice qualities in reducing some airborne pollutants. But if we are talking about very good titanium dioxide, it's expensive for the construction materials. So we have to find a balance between performance and cost, because traditionally we are not talking about biotechnology applications that has some capacity to incorporate some costs. We are talking about construction, so we should bear in mind that we should always develop sustainable materials, but at the same time affordable, so allow to enter the market. Otherwise, it will not be possible. So final remark to your question, yes, is something of interest, is something that we can think about it together. And yes.
Thank you very much.
Does anyone has a last question? I had one question, but you answered it at the presentation. So if nobody in the audience wants to do another question, I will present the next presenter. So I don't know. So I will present the next presenter. I don't know if Charlotte is here.
Yes, I'm here.
Okay. So just to check if you are here. So our second presenter is Charlotte Bandenhorst, whose presentation title is Novel Circular Economic Approaches for Efficient Extraction of Valuables from Spent Lithium-Ion Batteries, next LID, recovery of anode graphite. So Charlotte obtained her master's degree in chemical engineering, cum laude, from the Northwest University in South Africa, and her PhD in geology from the University of Johannesburg, also in South Africa. Currently, she is a postdoctoral fellow at Departamento de Geociências, Ambiente e Ordenamento do Território of Universidade do Porto in Portugal. So, Charlotte, the floor is yours.
Thank you. Okay, good afternoon, everybody. My name is Charlotte Badenhorst, and today I will be talking about the recovery of anode graphite from spent lithium-ion batteries. And this project forms part of the SWYP collaboration. Okay, introduction. So in this diagram, I've plotted lithium-ion battery components in relation to the European Union's critical raw materials list of 2020. So as you can see, natural graphite, lithium, and cobalt are all classified as critical with a high supply risk and great economic importance. Oops. Nickel, aluminium, copper, and manganese are not deemed critical at this stage. However, they have great economic importance. Okay, so currently it's estimated that around only 5% of lithium-ion batteries are recycled globally. In Europe, the dominating recycling technology is the Umicore process. However, it has some shortages. For instance, in the smelter, natural graphite and volatiles are burned to hazardous gases, and natural graphite, a critical material, is being lost. Also, lithium, which is also a critical material, is diluted in the slag phase. So the intention of the ERAMIN SWYP collaboration is to address these shortcomings and develop a number of new battery recycling technologies. So we're looking at safe shredding operation, electrolyte and anode graphite recovery, and lithium enrichment. So the partners involved are from Sweden, Finland, Italy, France, and Portugal. And here in Portugal, we are specifically concerned with the recovery of the anode graphite. So one of the main problems we were facing in recovering the graphite was the PVDF binder. So the binder is sort of a glue that glues all of the different components in the battery together. And you cannot really recover any component without removing the binder first, which is quite a challenging task. Some researchers suggest using NMP. However, it's very toxic and expensive. You can also use roasting or pyrolysis to burn the PVDF. However, then it leads to hazardous emissions. So in our project, we are trying to use milling, sieving, separation techniques, ultrasounds, and attrition to simultaneously remove the binder and recover the graphite. Okay, so in terms of my methodology, we started with some sample characterization. Then I've tried and tested different technologies to try and remove the PVDF binder. Also different technologies to separate the graphite. And lastly, we've combined all of the aforementioned information into a process flow diagram. And this process flow diagram I will today present to you. Okay. Yes, so the sample I obtained is a black mass sample. So in other words, it has been dismantled at the recycling plant. Oopsie. So our first step was to do some size separation at 250 microns. So this was because the plus 250 and the minus 250 micron fractions are different in composition. So they require different separation technologies. So the plus 250 microns fraction, we started with a density separation step in which we removed any polymers, liberated PVDF and silicon rods. Then we've done another size separation in which we obtained the plus 500 fraction, which was enriched in copper, aluminium and polymers. And although it's not part of the scope of our project, we've also noticed that you can use electrostatic separation to separate the different components in this fraction. However, we are more concerned with the 250 to 500 microns fraction, which is enriched in graphite. So in this specific fraction, the graphite occurs as anode chunks glued together by PVDF. So in order to remove the PVDF, we tried ultrasound technology. So in order to find the optimum conditions for ultrasound, we've created these very thin forms of metallic tape and casted on top is PVDF binder. And as you can see, after ultrasound, we managed to actually crack the binder. Yeah, so this is just taken with a fluorescence light. So the green is your binder and the metallic tape is the black. So you can see how it cracked. So after establishing the optimum conditions, we applied it to our black mass sample, and you can see we have a product of very pure anode graphite. In terms of the minus 250 microns fraction, so in this fraction, graphite occurred as particles and covered with this very small or fine lithium metal oxides. So once again, we used ultrasound to remove these fine particles from the surface of graphite. We then did another size separation at 25 microns to obtain a very pure anode graphite product. The 25 to 250 microns fraction, we subjected to attrition and density separation to obtain also a very pure anode graphite product. In conclusion, so we've designed an integrated beneficiation process to recover graphite from spent lithium-ion batteries. The graphite can subsequently either be used, reused in batteries or for other valuable applications. So our process is efficient, it's environmental friendly, and it contributes to the circular economy model. Possible future work entails further optimization, chemical and mineralogical analysis. We're thinking of a possible patent, economic and energy analysis, and actually testing the recycled material in batteries. So thank you very much for your time. If there's any questions, please feel free to ask.
Thank you so much, Charlotte. Your presentation was excellent. I don't know if someone in the audience wants to ask a question. Or I will ask a question. What is the percentage of recovery of these materials from this work?
Okay, so at this stage, we haven't done any quantification yet. We've only used the same images to get a general idea if it's successful or not. So the next step is to do quantification, and I will let you know
okay,
the
nice.
results. Okay, thank you.
Thank you. Andrea?
Thank you, Charlotte, for your presentation. And did you use the recovery graphite in any application? Did you have to do it, or you expect to do it in the future?
We haven't done it yet. Unfortunately, my postdoc will come to conclusion September. So I don't think I will be able to look at the application, but definitely that's a good idea. We can either reuse it in the batteries or find something else. So yes.
Thank you.
Thank you.
Guilherme?
Thank you. Thank you, Charlotte, for your presentation. More than a question, my question was in the same sense that Professor Andrea. So was to ask you about the application. So my question is already answered. So I just take the opportunity to congratulate you for your work and keep up the good work. And thank you for sharing.
Thank you. Thank you very much.
So anyone has a final question? And I think I'm going to move to our third presenter.
I think there is a question from Tiago still.
Tiago? Oh,
Yes.
I cannot see because let me see if you have some. You have a from Tiago. Tiago, do you want to speak or?
I can see the question. So you want to know more about the ultrasound?
I'm curious about the ultrasound step that you made. I'm not sure if you glue the powder on a metal foil or a metal plate. It was not that clear for me. I was interested to know.
It was a metal foil.
Okay.
So we bought some tape, you know, those metal tape.
Okay,
and then
like copper tape?
Yes, exactly.
Okay. Okay.
Yes, and then okay, thank you.
Okay, thank you.
Thank you very much.
Thank you so much, Charlotte, once again. So now I will welcome our third presenter, Amir. Okay, Amir Zania, whose presentation title is Molecularly Imprinted Polymers for the Enrichment of Phenolic Compounds from Winemaking Residues. Amir is a PhD student at Engineering Faculty of University of Porto and a researcher at Polytechnic Institute of Bragança. Amir's work focuses on the synthesis and application of molecularly imprinted polymers in the valorization of winemaking residues. His objective is to achieve functional MIPs, the molecular imprinted polymers, able to enrich polyphenols for further integration in pharmaceutical, food, and cosmetic products. So, Amir, the floor is yours.
Thank you very much. Okay, need to share my screen. Okay. Good afternoon. So my name is Amir Zania, and I work on some type of materials that are called molecularly imprinted polymers. So a basic outline of this presentation. So I will present the objective and the motivation, why I'm focusing on phenolic compounds, what is these types of material, what are they, how we make them, and their application. So as we all know, Portugal is a big producer of wine and also other Mediterranean countries, Tunisia, Italy. And like any production, we have wastes. And in this case, we have a lot of grape pomace and diatomaceous earth, wine leaves, examples of waste that are generated during the winemaking. And actually, these wastes, they contain a lot of polyphenols, as you can see here, different families of polyphenols, which are very valuable and can be integrated in many industries, mainly pharmaceutical, cosmetic, and food industry. So our approach is to take the residues, okay? We make an extraction. So we have a liquid phase, and then we pump that extract through a column, and that column contains a MIP, a molecularly imprinted polymer, which is the material that we are supposed to make and we are making, okay? And that material will be able to separate in a preferential manner the different phenolic compounds in order to obtain different fractions. So this is just able to show you the amount of polyphenols that exist in the different wine making residues. Okay, I will not dive into the details, but we have plenty of polyphenols that can be used in the industry. Okay, so now to talk about the main core of the work, actually, which is molecularly imprinted polymer, or abbreviated SWYP. So to make this, we take the template, a phenolic compound, and we mix it with some functional monomers. We do the assembly, okay, which is a type of interaction between the monomers, the functional monomers, and the phenolic compound. Then we make the polymerization around this polyphenol, okay. Then we remove the polyphenol, so we have a cavity, and this is the meat, actually, okay. And then we can use it, okay, in a process called zero binding. We can use it in our adsorption system. And at the same time, we have like another, like a same material, but it's called NIP, which is made in the same manner, but without the template. And this is like the blank and the control experiment of our polymer, let's say. Okay. So how exactly like they interact? Well, there are different types of interaction, and they can be divided mainly into non-covalent and covalent. In non-covalent, mainly hydrogen bonds, PP stacking, and hydrophobic interactions. And in covalent interactions, well, there is a covalent reaction, as you can see. This is the example of quercetina, this blue molecule, as you can see, which is a flavonoid. So based on this interaction, we will be able to interact with a polyphenol. Okay. So this is another example. For example, we have this monomer interacting with ferulic acid, which is a phenolic compound, obviously. Another example with quercetina. And if we use many, like for example, more than one functional monomer, we can create more specific cavities. Okay, it's kind of like a Lego game, you know. We can create really like specific cavities based on the different functional monomers that we use around the phenolic compound. Okay, so our strategy begins by targeting, actually by choosing the target, which can be phenolic acid or flavonoid, or yeah. And then we study the interactions. We choose the adequate monomers. We choose the adequate cross-linkers, the solvents, and then we have different types of reactions that we can do, polymerizations, okay, controlled, non-controlled, and different ways of polymerization, like thermal or through UV. So yeah, okay. Also, another line of our work, actually, we use hybrid polymers, which are very interesting materials because we can incorporate natural materials like cellulose or cork. And on top of that, we make grafting of polymer chains, okay? And this is very interesting because first of all, it's a sustainable manner to produce this material. And second, it promotes the adsorption of the polyphenol. So this is a real example. Actually, this is a scanning electron microscopy of cellulose before grafting. It was like 26 micrometers, the size, okay? And after grafting, we can see like it became 53 micrometers, okay? Okay, so the applications of these NIPs. So the first application that I'm going to show is the separation of phenolic acid. In this case, we have two different phenolic acids, caffeic and ferulic, and we are using a material called boronic acid, which can interact with the cis-Joule function, highlighted in red here, as you can see. So with this experiment, we are able to bind in a preferential manner the caffeic acid, which allows us to separate the two phenolic acids from each other in a mixture, of course. Okay, this is the data that verifies what I was saying. Yeah, it was like we analyzed all the fractions by HPLC, and we saw like that the retention was more preferential to the caffeic acid than the ferulic acid, which is our objective. Okay, so another application of these materials, we use them in a process called solid phase extraction, in which we put our material. You can see here it's kind of blue like the sea, yeah. Okay, and then we put, like, for example, two compounds, 1 and 2, and we have what you call the loading step. Okay, then we have the washing, and with the washing, supposedly the compound 1, which should bind to the material because it was made to attach to compound 1, we only bound to compound 1, and the other compound will dilute. And at the end, the elution phase will allow us to recuperate our desired compound. So this type of experiment. We use it a lot, and as you can see here, we synthesized a lot of materials. As you can see, each name is a material, and different materials like that are specific to ferulic acid, polydatine, quercetin, which are all phenol compounds. And also we compare to commercial materials. These are retention bars, let's say. The higher the bar, the better the retention, yeah? And here you can see highlighted by green, okay, in those rectangles. We can see some imprinting effects. Why? Because simply we have nip and nip. Remember, I told you we make the nip and we make the nip. So if we have a better retention in the nip, like you say, you see here, then the nip, like focus on the blue one, right, for ferulic acid, it means that we have an imprinting effect. Same principle here. This material was made for quercetin, and it has a better retention for the quercetin with the nip. Okay. Further application of this material, we took diatomaceous earth, which is a material used in the winemaking residues and used a lot in the filtration. And actually, not a lot of research was made about this residue. So we are focusing on it for right now because it's very interesting. So what we did, we made an extraction. Well, we just read it in the UV, as you can see. We had 3 picks, and we are going to make a screening process. What it means, we are going to pass this extract through a lot of materials. And I'm not going to dive again into the details, but you can see from here the loading step to the 4th step that we have this inversion of the colors, right? Which means like the materials are retaining the different phenolic compounds in a different manner. And this is a screening test. It means like we are after going to choose the best candidates to include in the adsorption processes. Also, we have the same experiment, like, which is a saturation. Okay, so we use the extract also of the diatomaceous earth, and we managed to separate like the non-Swiss gel compounds from the Swiss gel compounds, as it is like highlighted by HPLC data. So yeah. For the conclusion on ongoing tasks, well, we work a lot on like hybrid materials. Now we are trying to incorporate like cork into our work. We use like also we are trying to, we are already working with olive leaves to recuperate phenolic compounds from there. And all of this like falls into the strategy of synthesis, characterization, and then assessment. Yeah. So I acknowledge, of course, this work was financed by Bacustech. Okay, and thank you for your attention. And if you have any questions, feel free to ask, please.
Thank you so much, Amir, for this presentation. Does anyone has a question? Otherwise, I don't know if someone is with Iskiel.
Yes, thank you very much, Amir, for your presentation. And I have a question about the stability of this material, because it's very important to know about the stability, because if it degrades, perhaps it can contaminate the extract. And if you want to apply this extract in, for example, in pharmaceuticals, in nutraceuticals, it's very important, that matter.
Yes. It's a good question, and actually we are making like materials like the adsorbents that are used in the chromatography columns, right? So after making the polymer, of course, it is stable. We know that it's stable because basically they only degrade really in very acid conditions or very alkaline conditions, which they don't exist like in the winemaking residues or olive residues or even the pharmaceutical entities. So. And also like after the synthesis, we are cleaning the material a lot of times, and we are like analyzing if it is clean and stuff. So there is no problem about the stability, let's say, because it's well structured actually, because we use another like compound which is called the cross-linker, which maintains the 3-dimensional structure of the material. So it will not collapse, only, as I said, if the conditions like are so acid or so alkaline, yeah, it will degrade the material, obviously. Like, and when I say so acid, I'm talking like 0 pH and less, not even 1 and 2. So yeah.
Okay, thank you very much.
Thank you. Thank you.
Amir, I have a question. I think it's related to this topic as well. But the column that you use is easy to regenerate in terms of the times that you are extracting, or do you have to? Or tell me.
No, I understood your question. Yeah, no, the materials, of course, depending on the recipe that we use, sometimes we obtain materials that are really hard because we make the absorption and then it is hard to desorb, which is not good, like from an industrial point of view. But at the same time, we make materials that really like show good regenerability, and we can absorb and desorb like in a rapid way, let's say, like, that is adequate to the industry. So yeah, that's why actually we are working with hybrid like materials, because they allow us like to obtain materials that are really good for absorption processes. They prove to be very efficient. Yeah.
I don't know if there's someone has a question. Last one. No. So I'm moving on to the next presenter. It is Marta. It's our fourth presenter of this panel, and whose presentation title is Green Diesel Production by Sustainable Hydroconversion Process Using Shrimp Shell Waste-Based Catalysts. And Marta is currently a master student in chemistry at the Faculdade de Ciências do Porto. And this project is a collaboration with Inovcat company, and is addressed to use the shell waste as raw materials to desirable value-added products. So, Marta, the floor is yours.
Thank you, Patricia. I will share the presentation. Okay. I don't share move this bar my
Do you need help?
Yes, to apply the slider, the presentation.
See if you are sharing the PPT or the presentation, because you probably...
The presentation, the PowerPoint, yes.
But are you sharing your screen?
Okay, sorry.
Because sometimes yes. You are sharing, yeah, now we are.
Now. Yes. Hi, I'm Marta. I claim to be here. I would like to thank the organizer committee the opportunity to present the work I've been doing my degree thesis at Faculty of Science of University of Porto and an Inovcat company, which consists in green diesel production by sustainable hydroconversion process using shrimp shell waste-based catalysts. The continuous waste generation and accumulation on planet is a significant global environment issue. In particular, approximately 6 to 8 million tons per year of marine shell waste are globally produced and deposited in landfills or back into the oceans, which composition can cause environmental problems and human health risks in coastal regions, including bacterial contamination. This problem has caught our attention and gives us a challenge. How can we transform shrimp shell waste into value-add products and materials contributing to the circular economy and environmental safety? This abundant and renewable resource has a huge potential as a raw material to prepare, for example,
carbon-based catalysts, cosmetics, fertilizers, among others applications. Since it is composed by chitin, protein, and calcium carbonate. Targeting the valorization of shrimp shell, the goal of my master project is to develop, in OFCAT company, is to develop efficient and robust catalysts using the shrimp shell biochar produced from shrimp shell waste extraction using water under subcritical conditions. It is important to highlight that these catalysts were functionalized with abundant and cheap transitions metals from a simple, clean and sustainable mechanical process using the ball milling process and avoiding the use of solvents and the workup procedures. After that, these catalysts were applied in catalytic hydroconversion of vegetable oils, fats and other biomass derivatives to produce green diesel. Why green diesel? Green diesel is a promising and sustainable biofuel produced from biomass-derived resources, and it is alternative to fossil fuels due to their similar physicochemical properties to address the demand supply for clean energy and climate change caused by global warming. However, this fuel is produced in presence of high molecular hydrogen pressures, high temperatures, and heterogeneous noble metal catalysts, which made this traditional approach economically, industrially, and environmentally unattractive. So it is not an ideal option. To overcome these drawbacks, we propose in this project to use water and formic acid as alternative source to generate in situ green hydrogen, avoiding the use of high pressure of molecular hydrogen, mainly produced from fossil fuel resources, the use of lower temperature than used in report works to produce a cost competitive and sustainable process conditions. In addition, the use of cobalt and nickel and molybdenum species stored in shrimp shell carbon-based materials is also an important approach, not only to contribute to waste management, but also to prepare efficient catalysts. In this way, we successfully achieve in these green operational conditions the 100% hydrogenation of model compounds of vegetable oils components like linoleic acid using a reference catalyst polyene in carbon. We are able to convert linoleic acid into oleic acid with only unsaturation, resulting in a partial hydrogenation and ester and aromatic compounds using the shrimp shell waste catalysts. Same behavior was with nickel catalyst using as a support and activate carbon, also prepared from biomass raw materials. This suggests an efficient contribution of nickel or cobalt species and bio-based support in the hydrogenation reaction. Under optimized reaction conditions, we are able to hydrogenate vegetable oils into unsaturated free fat acids and probably some hydrocarbons, and we are now characterizing and identifying the obtained products. It is noteworthy to mention that the peaks corresponding to the glycerol part disappear, which is indicative of the hydrodeoxynation. It is also possible to evaluate the potential of these catalysts in the hydroconversion of furfural, one of the most popular platform moleculars obtained from biomass biorefinery, into levulinic acid and derivatives with industrial application as biofuel additives. To finish, it is worth pointing out that is very interesting to combine different thematic fields in a single project, dedicate
to waste management and the development of new sustainable and catalytic process to produce green diesel, contributing to the circularity. So far, we have been succeed in the hydrogenation of vegetable oils and lignocellulosic compounds, both from biomass, but we want to go further, developing this sustainable economical approach to obtain hydrocarbons. The next step is using the waste cooking oil as a feedstock under the already optimized catalytic hydroconversion conditions. Thank you for your kind attention.
Thank you so much, Marta. I have a question. I don't know if someone has a question. I don't have the knowledge about this area, but I'm quite interested in those results. I want to ask if it's possible to use even milder temperatures in the process. Or
yes, it's an excellent question. We use approximately temperatures lower than 300 degrees, and it is possible to hydrogenate the model compounds like linoleic acid and refined oils to optimize the reaction conditions. And the next step, I say, is use vegetable oils in these temperatures, and I hope that it is work in these conditions. Yes.
Yeah, because the vegetable oils that you mentioned is used, right?
No, not yet. We already optimized the conditions to be applied in this use oil. It's a key idea of this project.
Okay. Thank you, Marta. Now Ezequiel.
Yes, thank you, Marta, for your great presentation. I have a question. It's about if you think about other applications for this kind of technology, considering that the idea for the next 10 to 15 years is to stop using combustion. So you think that you can, by this reaction, to produce another material or another kind of use to your work?
Yes, we are working with biodiesel production in Maya, and they are very interesting in this green diesel tools as additive in the incorporation in biodiesel to improve their physicochemical properties to be used in diesel blends. But yes, I believe that we can use in other fields like new pigments, cosmetics, fertilizers, animal feeds, because the shrimp shell it's composed by other compounds, chitin and protein that can convert in these products.
Thank you very much.
Does anyone has a question? Is that we have here a question from Gonçalo Moreira. Is that company in Maya main.bio, the company that you were talking about?
And company in Maya is an off-cut company that has already biodiesel factory and work in the develop the catalyst to be applied in the biodiesel production. Is localized in Maya.
Hope it answers. So thank you so much, Marta, for this presentation.
Thank you.
Now I will introduce and welcome our fifth presenter, Fábio Simões. And whose presentation title is Circular Economy Approach to Construction Materials Incorporating Paper and Pulp Industrial Waste. To present Fabio, Fabio is a PhD student in civil engineering at the University of Aveiro, and his doctoral project is focused on the incorporation of waste as alternative raw materials in construction products. So Fabio, the floor is yours, and you can start.
Thank you. Good afternoon. Thank you to share my work. I will share my screen. Can you see it?
Yes.
Okay, my name is Fábio Simões, and my colleagues in this work were Helena Paiva, Hamid Malagi, Miguel Moraes, and Victor Ferreira. We are all from the RISCO Research Unit in Civil Engineering Department of the University of Aveiro. This work is about circular economy approach to construction materials incorporating paper and pulp industry wastes. This work includes in my PhD. What is the problem? Linear production, take, make, dispose, have contributed to scarcity of raw material and to the increased waste production. For this reason, pulp and paper industry is a large producer of wastes that are deposited in landfill. At the same time, the construction sector is an intensive consumer of the natural raw materials to apply in different construction works, like buildings, roads. Where is the solution? One solution can be a circular economy approach plus valorization strategies for alternative feedstock materials, where wastes are used as alternative raw material for other industries in order to preserve our life in the planet and the natural resources. What is the case study? This case study aimed to follow and insert circular economy approach to construction materials through industrial symbiosis. Thus, two wastes, dregs and grids from the pulp and paper industry were used as alternative raw material in bituminous mixtures for rooftop surfaces and test in real scale operation. How did it apply? The demo pilot was divided in linear solution and circular solution. The linear solution produces a section of a road surface with the reference bituminous mixture, such as AC14 surface according to guidebook of the Infraestruturas de Portugal. This mixture used a bitumen and natural aggregates that were removed on the earth. After that, these aggregates are transported to bituminous central. Then we produce the mixture. After we apply the local application. At the same time, dregs and grids are deposited in landfill. On the other one, circular solution, dregs and grids are avoided to landfill, but we need to make a pre-treatment to remove some constraints like a moisture and particle size. We asked the waste manager in order to transport it to your local the pre-treatment. After we transported to bituminous central for producing the AC14 surface with dregs and grids, the crash limestone from the reference bituminous mixer was partially replaced 4% by waste. The time production and application of the new bituminous mixer was similar to the reference mixer. How did it evaluate? Previously, in laboratory control, the waste were evaluated according to the properties of the guidebook of the Infraestruturas de Portugal. One property that must be complied, the requirement is final quality. The results must be less than 10 grams per kilo. At the same time, we evaluate the particle size of the wastes. The results show that are similar to crash limestone, 0 to 4. During the implementation of the road surface, samples were collected to produce a Marshall specimens in laboratory in order to evaluate different properties, particle size, void, stability, and flow. The results show that bituminous mixture with dregs and grids are suitable for a thin surface requirements of the guidebook. After the technical performance, the sustainability of the linear and circular solution was evaluated for environment and economic and social dimensions. The life cycle assessment LCI has adopted as a methodology to evaluate each dimension. We consider 1 meter square of the bituminous mixture for the construction of the surface layer with 5 centimeters of the thickness as a functional unit, whose different impacts for environment, economic, and social were calculated according to this functional unit. Each dimension's circular solutions show a reduction of the environment cost and social impacts. At the end, this solution as seen as possible and deliverable gains in sustainability without affecting its standard technical performance. For example, environmental impacts of the circular solutions can be reduced between 0.2 and 2% compared to linear solutions. This work was made under the support of the European H2020 project paper chain and allowed the collaboration with other European companies and research centers such as Action, LGI, Tecnalic, Geiger Institute, and Portuguese partners Navigator, Universidade de Aveiro, Megavia, and Reis. Thank you.
Thank you so much, Fabio. It was really interesting, your presentation. And what are the future prospects of this research, such as next steps, new trials?
The next steps, we need to solve some law problems, like to use in construction products. You need to remove the law about waste. You need to disclassify waste. And to next, after the next product, we need to achieve a CE marking.
Does anyone has another question? No. So if nobody has a question, I have just one curiosity in terms of the life cycle assessment. Even though the reduction, which was the category of impact that has the greatest reduction, like the 2%.
2%. Can I check? So please.
Yes. Just to.
Global warming potential.
Exactly. Well, thank you so much, Fabio, for your presentation. So now I will welcome our presenter, Srishti.
Hello. Yes.
Am I saying right?
Yes.
Srishti. So I will present you. You are the sixth presenter, and your presentation title is the contamination of food-grade polypropylene via supercritical CO2 to close the loop towards circular economy. Yes. Srishti is a junior researcher in the University Católica Portuguesa at Porto, and she's working in bioproject which complies the development of packaging material biodegradable and with active properties for food preservation. So, Srishti, the floor is yours.
Thank you very much for the nice introduction, and I'm really happy for all the presentations that I got to see, and thank you for this opportunity. So I will be presenting my work that I would perform during my master thesis, which is decontamination of food-grade polypropylene. So the presentation would be following background and then experimental of protocol and observation. As for the background, we know there are many PET recycling techniques that are already approved and are working. But when we look at of those for polyolefins, they are very less as compared. It is because of the thermal instability and the additives. And therefore, we wanted to concentrate on polyolefins. Now, polyolefins are the two sectors, which is polyethylene and polypropylene. We concentrated on polypropylene. So in our work, also we, like when talking a bit more about the introduction part, is when you look at polypropylene through literature, and also we perform screening analysis with some polypropylene materials, we found out that there are many chemicals or additives that actually affects the recycling technique, and their degradation can result in difficulty in recycling processes. Therefore, the mechanical techniques that are used for polyethylene, that is polyethylene terephthalate, which is PET, can't be extrapolated directly. We also needed a process that could be done on a lower temperature scale because of the thermal instability that I spoke about before. And therefore, it accounts for why we were working with polypropylene. And thus, we wanted to have a process that could be used as a super cleaning process. So therefore, we used decontamination of polypropylene by supercritical carbon dioxide. Our experiment was also in line with EFSA's approach, which suggests that in order to demonstrate a recycling procedure, we should incorporate in our experiment the use of prior intentional use chemicals and also misuse chemicals, and thus form the protocol of our experiment. We used beverage cups for our analysis, and we compared the results of polypropylene with that of polyesters, which is polylactic acid and PET. We contaminated our sample. So we had cut the flakes in 5 into 5, cut the cups in flakes, and we contaminated our sample using surrogates that were recommended to us by the food safety authorities. And also to obey the rule, we also considered intentional use of the beverages. We considered markers from beer, cola, and orange. And for misuse, we considered markers from cosmetic and gasoline. And then in order to decontaminate, as I already said before, we use supercritical carbon dioxide. We also tested different conditions in order to optimize decontamination efficiency. And we quantified in order to find the decontamination efficiency using GCFID. For the decontamination procedures, we use different parameters, like I said, and we were able to put them in different sections and have an observation to this results, which was, we studied the effect of surrogates, time and temperature. We have used 10, 30 and 60 minutes for the decontamination, and to obey the rule to not have high thermal, high temperatures in experiments, we've used 60, 70 and 80 degrees. And we kept the pressure constant, which was 200 bar. In this slide, you will also find the supercritical fluid extractor that I have used and a schematic diagram for it. Here in the slide, I have presented all the results that I have obtained with different parameters and all the surrogates that I have used. But to give a more pictorial representation, I would move on to the next slide. So basically looking at the figure on the right-hand side, you would see that the average average decontamination efficiency of polypropylene is higher than the polyesters. It is because of the fact that the diffusion coefficient of CO2 is higher for PP than for the other plastics, and that also concludes our research. In order to study the different effects, we saw that the lighter weighing compounds had higher decontamination efficiency as compared to the heavier ones. We also saw that the compounds that are volatile had higher decontamination efficiency as compared to the semi-volatile ones. In order to study the effect of time, we observed that PET was the only plastic that had an influence of time with respect to supercritical extraction. And this didn't have an effect on PLA and PP. We also studied effect of temperature while doing experiments on supercritical extraction on polypropylene, and observed that there was not much significant effect of the temperature, although in general. But if you look at like benzophenone, for instance, you would see there was slight decrease. It is due to the fact that when increasing temperature, the diffusion, the density of carbon dioxide decreases. But still, all in all, you can conclude that supercritical extraction was able to decontaminate polypropylene. And now that we have obtained a material that could be used as a recycled material, we wanted to evaluate our material. Therefore, we checked a few other analyses. We performed physical property assessments, and we observed that there was no change in the physical identity of the plastic itself if it was virgin flakes or when treated with supercritical carbon dioxide. And we have used rigorous conditions with this extraction. And we also checked for sensorial analysis, and there was no significant odor change. And the overall migration also didn't have any effect on after the treatment of supercritical carbon dioxide. Last but not the least, we also performed another screening assessment to check for any degradation. And we actually found out that there was a reduction of 90% alkanes, which are one of the major resultant components that I was talking before, which contributes to NIASs, to non-intentionally added substances, and can and doesn't help in the recycling procedures when we are talking about mechanical recycling. So all in all, to conclude my work, we performed polypropylene decontamination using supercritical carbon dioxide, and we obtained higher decontamination efficiency of PP. In terms of PET, we observed processing time influence, but for the scope of our project for PP, we didn't experience a significant change in temperature and time on the decontamination itself. We only tested for one thickness. And we also wanted to say that supercritical carbon dioxide treatment does not have a change in it does not have a change on physical and sensorial identities of the plastic itself, and also doesn't affect overall migration. It additionally has an impact on reducing other potential migrants. And to end my presentation and to list the future perspective of this project would be, we will be using real-time contaminated flakes in order to have more variability and to perform a real-time assessment of the flakes, and also to incorporate co-solvents in order to have the decontamination efficiency more optimized, like I was talking before. But yeah, thank you very much for your attention, and I welcome the questions.
Thank you so much, Srishti. I have two questions. One question, right? We all know that plastic can be good in a way and bad in the other, but good in a perspective of food safety, because how can I say, when the appearance of plastic in the food industry, it was a great step for the industry. And yes. I ask you if you believe that this contamination process could be the future of, for example, the decontamination of reusable plastic materials for food industry.
Yes, indeed. Yes, indeed. This was also what my project was based on. It was, we wanted to have a demonstrate a procedure that we could obtain plastic that could be used as a food grade material. And actually, there's already a project that works on a similar experimental technique, which is of next loop. So it's very much possible to have a plastic that could go back to the food technology. I'm talking about polypropylene or polyolefin in general, but there are already a lot of procedures in terms of PET, and it's already like 100% recycled. So yes, indeed. I really like this project, and I feel that it could very well go and be something substantial. Yes.
Thank you so much.
Thank you so much for your question.
Yes, thank you for your presentation.
Thank you.
I have a question.
Oh, okay.
Do you think that this kind of process it's now viable because, or you think that we have to wait that the technology improve to be more cheaper, or to be because now for food industry I don't know if it is affordable.
Yes, no, I agree. And also the fact that we can't really look back that virgin flakes are way cheaper than extraction. But in hope that one day it would be, yes. And at the end of the day, we all are focusing on a circular economy prospect. So even though there are some things that you see would be more expensive, buyers are going for that. Instance, in Portugal, you have Mercadona that uses biodegradable films, although they are still way expensive than the polyethylene plastics that are being used by other commercial brands, but they are still incorporating it. So yes, I hope, yes.
Yes. We hope this.
That's also the motive of our work, circular economy. Yes.
Yes, and the supercritical is very useful for other processes. So
yes,
we hope that it's in the future it become more cheaper because we need it.
Yes, indeed. Thank you for your question.
Thank you, Ezequiel. Does anyone at the audience have a final question? I don't see. So since there are no more questions, I'd like to thank all of you for all the amazing presentations in this panel, and really interesting from different areas of working, construction, plastics, or biodiesel battery. So it is quite a great panel. So I'd like to thank you, all of you, and I'll return now to Ezequiel. So thank you.
Thank you, Patricia, and speakers for this excellent session. And with that, ladies and gentlemen, we come to the end of the online conference, Circular Economy, Make It Happen, second edition. I remind you that this conference was organized by Smart Waste young professionals. Please visit the website, share in the chat to know more about the group if you are interested. So this conference showcased the best of research in circular economy that is being carried out by young professionals in Portugal. And as Marta mentioned previously, an award will be attributed to the 3 best presentations. The first place will receive a scholarship to participate in ISWA Swiss 2022 Winter School in Texas, USA. The second and the third places will receive sponsorship for participating in training or education initiatives. We will then be announcing the winners the next days through the Smart Waste Portugal communication channels. We will also publish all our presenters' abstract in the conference book, which will be made available on the Smart Waste Portugal website soon. On behalf of all the organizers and committee members, I would like to express my gratitude to all of our wonderful speakers and participants for making this event a really success. We hope you have enjoyed these sessions and enjoy the rest of your days. Thank you very much and see you soon.
Goodbye.
Thank you. Thank you. Goodbye.
Thank you. Goodbye.